Okay, so in this video, I want to briefly explain how things work. So programming is pretty much writing a bunch of things in a file, letters, words, and numbers, and then the computer is going to understand these words and is going to perform calculations based on the words you write. And each programming language has a special syntax that actually means something to the computer, and then other keywords don't mean anything. So for example, in Python, if you write lambda, it's gonna treat that keyword with a special meaning. And if you write cat, then it doesn't know what a cat is. And same thing on JavaScript and any other programming language. And then I'm gonna explain more about this on the next video. But the reason why I wanted to do this video is to show you what are the main keywords for Python and JavaScript that actually mean something. I didn't write all of the keywords here because there's a lot to explain still. So I'm gonna talk about other stuff. But these are the keywords some of the keywords that are used 80% of the time in Python and JavaScript. And I also wanted to talk about the general concepts here, because when you're starting to learn something, you don't know what you don't know. So these keywords are gonna help you understand stuff that you're not aware of yet, and they are more advanced concepts. So I would suggest that you write them down and then you search for them on your own time. I'm probably gonna make videos about them in the future. But yeah, so the one that I want to talk about here is software design, because it was something that I was struggling in the beginning. I'm also gonna talk about some other ones, but yeah, software design is pretty much as you start typing a bunch of code, then you can't put everything in one file because it becomes too big. So what happens is you're gonna have to split the code between files, and then in every programming language they're gonna have a system that allows you to connect different files. And then as the project goes, you're gonna have multiple different directories and multiple different files, and all this code connected between files. And people invent systems to deal with that, and the name of this category of things is called software design, and that's really important to understand. Then some of these keywords here that I wrote down are also related to the way that the programming language communicates with the operational system, because the operational system is one thing, is the way that your computer deals with all the processes that it has, and the programming language is connected to the operational system. I'm going to explain more of this in the future videos because there's too much stuff, so I don't want to talk about everything now, but that's roughly what's happening. So the programming language communicates with the operational system communicates with the internet when it has to and when it makes sense, and a lot of these keywords are related to that. And then this keyword here, srlatch, is something that is related to how the computer remembers things, which was also something that I really struggled in the beginning. And also these other two keywords here are very important to understand about the actual hardware level of how things work. And yeah, the rest I'm not going to talk about it now because I'm going to make videos about them in the future. Also the ones that I've talked about, I'm going to make videos, but I just want to briefly talk about this because I think it's important. And there's also this channel from this guy here that I want to recommend. Their videos are really good, and they're going to help you understand a lot more about the hardware level, the srlatch that I talked about, arithmetic, logic unit, and registers. And especially this playlist here, they're going to talk about this, and these videos are really good, so I really recommend that you watch them. It's going to help you understand things in the future. But yeah, on the next video, I'm going to explain why is it that some of these keywords have meaning and other keywords don't have meaning. I'm going to explain the history behind how things evolved in the very beginning until the way that things are now, so that you're able to make the distinction of when certain keywords mean something and when it doesn't, and why is that the case. So yeah, see you on the next video. Okay, so what I have here is a statement in Python. This statement doesn't matter that much. I'm just using this to illustrate a point later so I can explain how everything works. But pretty much everything that you write inside of this parenthesis here after this print statement is going to show up in here, down here. Let me run this. So that's pretty much what this statement does. So I have the statement right here. And now let me go back to this. So what I want to explain is that the screen that you see in the computer is pretty much a sequence of pixels. And you can think about each pixel as being a small little box with 3 different numbers. And each of these numbers represent a color, which is red, blue, and green. And the combinations of these colors determine what's gonna show on the screen. So a good way to think about it is the screen is just a bunch of different numbers. And all that the computer is doing is receiving a bunch of inputs and then doing calculations on these inputs and determining what's going to show up on the screen based on those calculations. So a good way to think about it is that our computer is just a fancy calculator. It just receives inputs and then does a bunch of calculations, and based on those calculations, it does whatever you tell it to do. And the way that it does that is by something called transistors. So I'm pretty sure you have heard of transistors, and they are things that allows us to represent binary, which each transistor is going to function as a 0 or 1. And then we can arrange these transistors into shapes, through geometrical shapes, or put them together, connect them in some ways. And the connection of these transistors is called logic gates, which I have 2 pictures here to show. So this is the representation of logic gates in schematics of computers. And through these logic gates, that's pretty much what we use to tell the computer what to do at the fundamental level. So just a bunch of impulses that are zeros and ones, which are the transistors, and then we arrange these transistors through some certain logic that we place by connecting them with each other. So the computer receives an electromagnetic impulse, and then through that arrangement of logic of these gates here, we are able to do calculations, which it is computation. So that's the representation of the gates. And you can see here the truth tables, each one has a certain logic, and then it gets really complex because the way that you arrange is going to change the instructions and so on. But then through these combinations of logic gates, we're able to do calculations. So what happened in the past is that through time, people realize that they are doing the same calculations over and over again. So they are essentially rearranging these logic gates and then sending impulses to these logic gates. So they send electromagnetic impulses, and then based on the electromagnetic impulse, the sequences of zeros and ones changes. And that change in sequence of zeros and ones is the computation. And that's the whole point of the computer. So through time, they realize that they are doing the same sequences they are sending the same signals, and then they are doing the same calculations over and over again. So binaries can be represented as decimals. So in this example, this binary here would be 4, and then this is 2. And then people realize that they are multiplying 2 by 4, getting 8 all the time. And then they use this 8 with another numbers and get 42. And then obviously it's a lot more complex than what I'm going to say here, but it's just so you get the point. And once they realized this, they decided to do something that allows them to, instead of typing the zeros and ones and sending the impulses, they start off with the symbol itself. And then they create a sequences of rules that allows them to just type the letter or the number 8 and get the impulses instead. So now, instead of rearranging the impulses so that every time this collection of zeros and ones becomes 8, through all these calculations, they start off with 8, and then through the sequences of rules, they arrive at the same sequence of binaries at the bottom level. And this process of starting off with the concept or the number of 8 and ending it up with the sequence of binaries that you desire is called a compiler. And this is one of the fundamental principles of programming, because that's pretty much everything that has been happening so far, which is people realize that they want to simplify common actions that are happening all the time, and then they create series of rules, and that's called compiler. And then through those series of rules, you're able to represent words or numbers and get a sequence of binaries at the bottom layer. And then with the sequence of binaries, you can have instructions of what's going to happen sequentially. And the way that letters are mapped are pretty much an agreement where a bunch of people decide based on a protocol that certain numbers are going to be equivalent to certain letters. So these are the main ones, UTF-8 and ASCII, the protocols, and it's pretty much an agreement. So people agree that 42 is going to be equal to QUET, for example. Each number is going to be equivalent to a letter. And then through this encoding, we're capable of representing letters because in reality, they are just numbers. But because of the agreement, we decide that the letters are going to be equivalent to those numbers. And then through the letters, we are able to write stuff, which ultimately arrives us at the point where we can use print hello world. And then through this statement, this is going to make it so that you have a sequence of binaries at the very base layer, which are going to work as an instruction. Then obviously this is a massive simplification. There's a bunch of different things that happen, but I want to be concise and explain as simple as possible, just so you can understand that what you're typing when you program is actually just changing the sequence of binaries at the base layer. That's what's happening. And the whole process of becoming good at programming is understanding the chain of connection of the higher level abstraction, which is the stuff that you are writing, and the whole path between this and the binaries, which is a sequence of compilers, which are translators between the high level concept that you write and how that concept becomes numbers, and then those numbers become binary sequences. So the way that I like to think about it is that each programming language is kind of like a country, where the lines between countries are arbitrary. They don't exist in reality, but then we agree that they exist, and because of that, different countries have different rule sets. And based on those different rule sets, each country is going to have a different way of living and communicating. So it's the same thing with a programming language. Each programming language is kind of like a little country, and within the constraints of the rule system from that language, you can write and communicate stuff in a certain way that the computer is going to understand. But if you move to another country, then the system of rules are going to be different, which is going to make the syntax of what you write different. But the underlying fundamental stays the same, because at the end of the day, all that you're doing is modifying the binaries at the base layer. It's just changing what information you're encapsulating in certain words through the differences in rule sets that change the meaning of what you write. So both Python and JavaScript comes from C++, C++ comes from C, and C comes from assembly. That's roughly the evolution. So Python has a bunch of stacked concepts that have a bunch of complexity that comes from all these different languages here until we get to binary. And that's one of the main concerns that I have here. And my priorities is trying to explain Python and JavaScript in a way that you understand the fundamental principles behind them and what you're actually doing when you code, when you type the words that are going to make the computer do something. So there's a small difference here as well, is that there's something called interpreter, and it's pretty much very similar, but Python and JavaScript are interpreted languages. And the only difference between an interpreter and a compiler is that the compiler translates the letters, the commands first, and then you get another file which is called an executable, and the executable is going to be the sequence of binaries itself, and that's what you're going to run. And the interpreter translates and executes right away, so it does the two things at the same time, and you don't get a new file. So the interpreter is translating this instruction here, print hello world, into a sequence of binaries and then executing right away, and the compiler is just translating this here into the sequence of binaries, and then you get a new file and then you run it. And that's pretty much the difference. So something that people talk about a lot as well, and is very important because it's fundamental, is data structures and algorithms. And what people mean when they say data structure, what they're pretty much saying is that this arrangement of logic gates here is pretty much the same thing, because this arrangement of logic gates are going to be the sequence of binaries that you get based on a certain impulse that you're sending, which is the input that you give the computer, which in the normal circumstances is a keyboard and a mouse. So every time you type on a keyboard, you're sending a signal. The signal changes the configuration of binaries here based on the logic gates, which is the hardware of the computer. So when we're talking about the data structures, they're talking about the arrangement of zeros and ones based on a certain impulse. And that's the two most important ones that I've seen talked about all the time that are directly connected with programming. Pretty much all of them are, but the ones that are more fundamental is stack and heap. And those two data structures are essential in order to understand what is actually going on in each instruction, what is actually happening at the base layer of the binaries. And I think that's pretty much it. So next video, I'm going to talk more about, I'm going to explain how stacks and heap work. Very simplified, in a very simplified way, but just so you have the understanding of what's going on. And yeah, and they are pretty much a good way to think about these concepts, is that they are an arrangement of zeros and ones at the base layer. So depending on what configuration of the zeros and ones you get, you're gonna call that a stack or a heap, in the same way that I explained here of this evolution here, where you get to this final concept based on this. People do the same thing where they represent a complex binary structure by calling it stack, but at the base layer is just a sequence of binary. So hopefully it's understandable, but yeah, I'm probably gonna put a picture at the end, maybe once I edit this, in order to represent this connection that I'm talking about of what is a stack and what is a heap. But I'm gonna explain more in the next video, so see you then. So to reinforce what I was talking about in the previous video, this is roughly what I mean by data structures and what other people mean by data structures. What's happening is that you have a sequences of zeros and ones, and then they form a structure, an actual physical structure in the hardware. And then people name that structure something. They give the name of a concept to it. In this case, I'm drawing a face here, and I'm calling the concept face. But in reality, it wouldn't be like this, because what you have is actually a complex structure of zeros and ones that isn't necessarily equal to the name of the concept that people give, but people give these structures a name, so it's easier to reason about them. And that's what a stack and a heap is, and that's what all the other data structures are about. They're just combinations of zeros and ones at the physical layer, and it's like you're taking a snapshot of the computer and you're calling that a name of a concept, and then people think about these things through the name of the concept because it's easier to understand. So I'm going to briefly explain stack and heap, the part that I think is important for you to understand, that is related to code, but obviously is more complicated than this. So do your own research. This is just the simple stuff. But here, let's say you have your file, and these are lines of codes here. So what's happening is the computer is gonna, or the interpreter is gonna read the file, and then it's gonna start putting things on the stack. Now, obviously, like I said, is an oversimplification, but just so you understand the most important things. So he puts the first thing that he puts on the stack is the last thing that is gonna take out. So it's first in, last out. So he puts stuff on the stack and then executes the lines. And that's usually the flow that a program is gonna have. And the reason for the heap is that sometimes, because each of these lines of code are like these structures here that actually occupy physical space on the computer, sometimes they are too big in order to fit in the stack. So imagine that one of these data structures is a line crossing through here from here, but the size of the stack is the face. So the line is not going to fit on the face. It's too big. So what happens is and this is done automatically for you in higher level languages, but the lower level languages, you have more freedom in order to deal with this sort of stuff. But what happens is, instead of putting the stuff on the stack, it's gonna go to the heap and put the code actually in the heap, because in the heap it has more space. And then instead of the code here, because how is gonna know that the code is on the heap? Because there's multiple different places here to be. So when it gets time to execute the code on the stack, how is it gonna know where is the code? So in order to know that, as soon as the code goes inside the heap, it returns an address, which is kind of like an ID number that is a link between, it says pretty much where the code is inside of the heap, and this ID is stored on the stack. So let's say it's ID 1. So now when it gets time to execute the code, it's gonna read 1, and then it's gonna see that it's on the container 1 in the heap, and it's gonna go and get the code and execute the code from the heap. And the reason why this is usually people try to avoid this is because there's always this trade-off between space and speed. This is always the dance that is going on when you're coding and when you're programming. The faster something is, the less space it can occupy. So usually all the optimizations on code are around this trade-off, and is one of the key fundamental concepts, I think, of programming. There's always this trade-off between how much memory you can occupy and how fast you want things to be. And usually in reality, it's going to be the shape of a funnel that things are always becoming. So with memory structures and with the execution of the code. But yeah, this is one of the reasons why Python, everyone says that Python is slow, and also JavaScript, and they're definitely slower than lower level programming languages, is because all these optimizations are already, they're not, you can't do these optimizations because they're already written in the interpreter, and you don't have a lot of space for complexity and nuance. But then the trade-off is that it becomes a lot easier to write the code because all the complexity is handled for you. So this is the trade-off you have to understand. The higher the level of the programming language, the easier it is going to be to write it and to develop it. But the more inefficient it's going to be because it has all these stacked concepts on top of it that are going to deal with these low-level things here, which is the management of the heap and the stack. So I think one analogy that I wanted to use to make this easier to understand also is that imagine if instead of code you had an elephant, and you wanted to put the elephant inside of the stack. So the elephant is going to be too big to fit on the stack. So the heap in this case would be like the zoo. And then you would have a zookeeper, and the person that has the elephant and is walking the elephant around is going to go to the zookeeper and is going to say, hey, can you store the elephant inside of the zoo? The zookeeper is going to say yes, and is going to give the owner of the elephant an ID card. And then the owner is going to go back to the stack and is going to store the ID card. So when it gets time to call the elephant to do a task, it's going to go back to the zookeeper and it's going to handle the ID, and then the zookeeper is going to get the elephant in the specific place that it is inside of the zoo, and then it's going to execute. And that's why it's slow. So yeah, that's one of the fundamental things, but obviously it's more complex, like I said before. So yeah, I'll probably talk about this more in depth in future videos. But next video, I'm going to talk about the data structures of the actual code, the main fundamental data structures. And then after that, I'm going to explain the methods and differences behind them, and start going more over the differences between Python and JavaScript. So see you in the next video. So these fundamental data structures that I'm going to talk about are the same in JavaScript and Python. First one is array or lists, and is like a vector. The best way to think about it is like a direction. It's just a representation of a direction. The other thing that is good to know about arrays is that you should prioritize doing them with items that are of the same data structure. And the reason why is because at the lower level, it is optimized to work with the same data structure. So if you do it in the way that is on the left here, it's not optimal. And in other programming languages, they don't even allow you to do this. You have to specify the type of the array as you initialize it. But in Python and JavaScript, you can do this, but it's not incentivized for you to do it. It's not a best practice. The next one is an object, and objects have key and value pairs. So on the left, you're going to have key, which is anything really that you want to put there, except things that change the size in memory later. So things like an array can change the size in memory after you declare them. So you can't use them as keys on the object, but the value can be anything you want. So the key is going to reference to the value, and the way that you access values in an object after you initialize it is with dot notation or square brackets. So you put the name of the object, and then you use the dots or the square brackets, and then you put the name of the key. That's going to give you the value that is equivalent to that key. But I'm going to talk about more about this once I talk about the operators and how initialization works. Then the next one is tuple, and tuple is pretty much the same as lists. The only difference is that you can't change a tuple after you initialize it, and lists you can change them later. And this has to do with the things that I talked about in the previous video, where these data structures are just structures of zeros and ones in memory. So that's the difference between them. Some of them you can change the size of the structure that is allocated in the computer after you initialize them, and then some of them you can't. That's the main difference between tuple and lists. And then the next one is a string, and this goes back to what I was talking about in the first video, where because everything is a representation of bits in the computer, the commands of the computer are representation of bits at the lowest level. If you want to write actual words in your program to pass them around or to represent something, then you can't actually use just words, because that would be considered as a instruction in the program. And in order to solve that issue, people came up with the symbols, which is the symbol on the left and the symbol on the right, and they both are used whenever you want to put actual text inside of the program for whatever reason. The next ones are self-explanatory, is integer and floats. And integer is any full number like 2, 3, or 675. And a float is any number that is broken down. So for example, any number between 2 and 3, like 2.5, 2.7, numbers like that, or even 0.0. So every time you put a dot on a number, it's going to view that as a float. And also in Python and in some other languages, you can represent, you can put an underline to represent big numbers, to write big numbers because it's easier to see. But in some other languages, you can't do that. And the reason why floats are different than integers is because it takes more steps to compute a float, because everything is binary or bits in the lowest level. So integers are an easier conversion from bits into the decimals, and floats takes more operations. And the last one is classes, and classes are fundamentally different in Python and JavaScript. So I'm gonna make a video about them later on, explaining the differences, because in JavaScript there is some nuances that I need to talk about. And then besides that, you have a lot of other data structures that are built with these data structures, but these ones are the fundamental ones in my view. See you next video. So the first operator that I'm going to talk about is the equal operator, and there is a difference between the way that the equality works in mathematics and the way that it works in programming. In mathematics, when you use the equal operator, you're saying that the two values are equal to each other, but in programming, what you're saying to the computer is that you want to store the value on the right inside of the word on the left. So whatever value you put on the right is going to be stored in the word you use on the left. And then from that point on, every time you use that word in the program, the interpreter is going to understand that the value you stored in the beginning is the one that is being changed. So in this example here, you initialize num equals to 0 on the top there, and then inside of the loop, you're increasing num by 10. So the computer knows that it's 0 in the first one, and then after the second one is going to be at 10, then 20, and so on. So obviously this is useful because you can initialize, the name of this concept is variables, so you can initialize variables and you can use them all over the program, and it's something that is really common and fundamental. And there's a difference between Python initialization and JavaScript. In JavaScript, you have to use the special keyword let, var, or const to initialize a variable, and in Python you just initialize the variable, you just write the word and make the equal sign and assign whatever value you want. And there are some rules on what kind of names you can use, but I'm not gonna talk about them very in depth now because I don't think it's worth it. But yeah, the difference between let and var I'm gonna talk in future videos because it's a more nuanced thing about JavaScript. But the difference between const and let and var is that when you use the word const in JavaScript, that means that you can't change the value of the variable later. So going back to the example that I said here, if you were using const num equals 0 and you were using JavaScript, you wouldn't be able to add 10 to num later because you use the word const. But if you use the word var or let, then you can modify the variable after initializing it. And the norms for JavaScript, a norm is simply a convention that people decide that it's better to write names like that so that it's easier to understand what's going on, but it's not enforced by the interpreter. It's not a part of the rule set of the language itself. It's just a convention. So the convention for Python is to use underscore for names. So if you have a variable that has two words, you separate them with underscore, but in JavaScript, the convention is camel case. So for each word, you're gonna start the next word with uppercase in the beginning. And so the first word is lowercase, and then every word after that is gonna be uppercase. Some of the other operators are these math operators. I'm not gonna talk about all the operators. I'm just gonna talk about the ones that I think that are important to not waste your time. But the math operators are pretty much, they work in the same way that mathematics works, and you can use parentheses to give the higher priority on the execution of the calculation, in the same way that you do in mathematics. The only difference is that you use the star to do multiplication and you use the double star to do exponentiation. So the other operators that I want to explain are these ones, and I'm going to start by the plus equal one. So doing the plus equal sign is pretty much the same thing as doing this. So for example, you initialize the variable equals to 0, so num equals to 0, and then you want to add 10 to that variable. So what you'd have to write is num equals num plus 10, but they did a shortcut, which is you can write plus equals 10 and it would be the same thing. So I think this is pretty self-explanatory the way that is written here. And you can do this with all the other mathematical operations as well, including with the greater than or lower than. So in the way that it is here, greater than and equal to, or greater or lower than and equal to. And those operators are used to test a variable against a value or any true. It's pretty much the same as mathematics. So this represents greater than, and when you use the greater than or equal, you're saying that the variable can be greater than or equal. So also pretty self-explanatory. And the other one in JavaScript that is a little bit more nuanced, and I'm not going to fully explain now because I have to explain for loops through or any kind of loop to be able to explain this properly, but is the plus plus operator. And the way that it works is pretty much like the addition. It adds 1 to the variable if you write it in the way that it is here. But there's a difference if you write it before the variable or after the variable. And the difference is if you write it before the variable, then you are adding 1 and returning that value after you add it. But if you do it after the variable, you are adding 1 and returning the variable the way that it was before. So the difference here would be that this expression on top would return I equals 1, and this would still return I equals 0, even though in both cases is adding 1 to I. So I'm going to explain this further because I have to explain other concepts to be able to explain this better. And the last ones that I'll explain in this clip is the /sign and this module operator, which is the percentage, and they are variations of a division. So the normal division, if you divide 5 by 2, it was going to give you 2.5, but if you use 2 slashes, it's going to discard all the remainder. So it's going to give you an integer instead of a float, and it's going to discard whatever is the float part. So in this case, we would return 2, and the percentage is a little bit more difficult to explain, but it basically gets us close to the full value as possible that it can. So in this case would be 4. If you're dividing 5 by 2, it multiplies 2 as much as it can until it gets to 5. And then it returns whatever remainder you have after that. So in this case, if you multiply by 2 one more time, you would get 6, which is obviously greater than 5. And you don't want to get the remainder, which is divided 1 by 2, which is going to be 0.5. So it gets to that point until it gets as close as possible. And then once it can't divide by anymore and get a full number, it's going to return whatever the remainder is. So in this case is 1. And then I'm going to take a bit more time to explain the equal, double equal operator and the triple equal operator, but I'm going to say now that the double equal operator is simulating the equality in mathematics, because the equal sign can't be used to verify equality because it's already used to assign values to variables. The double equal sign is used to verify equality. So it works pretty much the same way that it does in mathematics. But the difference here, when you have the triple equality in JavaScript, is that both of these values are used to check for conditions. And the difference is that the triple equal operator checks for a stricter form of equality than the double operator. But to explain the difference in them, I have to explain what are the false values in JavaScript and Python. So basically in programming, you have this concept of a Boolean, which is true or false, and it works in the same way as reality. So true is true and false is false. But then you can use that to compare different values. So you can compare a variable to see if it's true or false, but different types of variables can also be false. Different types of data types and data structures can be false or true in each language, and that's when JavaScript gets a little bit confusing. So I'm going to show all the false values in JavaScript, and then I'm going to show the difference when you check for the condition with the double equal sign and the triple equal sign. So false values are any values that can be considered as false in the language. And here I have a list for both Python and JavaScript of all the false values. So in Python, if you put an empty list or empty tuple and so on, it's going to be considered as false. So if you make an equality check in Python with this to see if it's equal to false, that's going to return true because these values are false. So as I was editing this, I realized I made a mistake. These values are actually not false. They don't equate to false. They're all variations of false. So the meaning is that it can represent something similar to false, which is that the lack of a value or variations of that, but they're not exactly equal to false. And that's the reason why you have several different names and classifications for this type of thing. And the same goes for JavaScript and these values here. And that brings me to the explanation of the difference between the triple equality and the double equality, which is in JavaScript, if you're only testing with the double equality, then if you make this condition to see if the string of 1 is equal to 1, to the number 1 is going to give you true, because it's not actually testing the type of the thing that you're writing. So in this case, it returns true. But if you use 3 equal signs, then it's going to return false, because it understands that one is a number and the other is a string. So that's pretty much the difference, and it's kind of annoying in JavaScript to have to test for that. And there are other nuances about this topic when it comes to the other operator, which is this nullish coalescence operator, which what it does is it does a different check based on the condition based on these false values. But I'm going to talk more about this later because I have to explain other concepts to talk about this. And here I have a spreadsheet with the list of explanations of the differences between these values, because they are all false, but there are small nuances in the difference between them. That's why you have several different values instead of just one. And here are the explanation. I'm not going to talk about it because you can just read here yourself. But yeah, that's pretty much it. Next video, I'm going to talk about the main concepts like for loops, functions, and things like that. I'm going to go over each one briefly. So see you next video. So in the next 2 videos, I'm going to explain the concept of control flow. And the first thing that I want to explain is the if-else statements, which is pretty self-explanatory. So you put an if, you write down an if, and then you put a condition. And if that condition is passed, you put whatever code inside that you run. In this case, I have print here, which is a statement in Python that allows you to show code inside of the terminal, which is this thing in the bottom here. And the equivalent for that JavaScript is console.log. And then after the if, you can put elif statements or in Python or else if in JavaScript, which allows you to put other conditions that are gonna run in case the first one fails. So if the first condition is not true, then it's gonna see if the second condition on the elif or else if is true, and then it's gonna run that. And then finally you have the else statement, which is if all the other conditions are false or they don't pass, then the code that is on the else statement is gonna run, and it is optional. So everything that is highlighted in red here is the fundamental part of the structure, and what is highlighted in green is the stuff that is going to change depending on the application that or the program that you are writing. And the stuff that is on yellow is the stuff that is optional, which is the symbol in JavaScript at the end of each line that is recommended to use but is not necessary. Another thing that I want to mention here is that sometimes you want to check for multiple conditions on only one if statement, and for that you use and or in Python, which is these special keywords here. So if you want to check if the number 1 is true and the number 2 is true, then you use and if you want to check if either one of them is true, use or. And the equivalents of these symbols in JavaScript are these 2 % here and these 2 things that I don't know how to say it. So the other thing that is worth mentioning is that the difference between using multiple elif statements or multiple if statements is that if you use multiple elif statements, then if one of the conditions is true, it's not going to run any of the other conditions. But in case you use multiple if statements, then all of the conditions will run regardless. So the last thing that I want to talk about is the switch statement. Python doesn't have a switch statement, but JavaScript has. And the way that it works is pretty similar to if-else statements, but it tests for whatever you put inside of the switch here for the condition. And then you can write multiple cases to test for values of whatever you put inside of the condition first, which in this case is number 1. So then after the case, you put whatever code you want it to run if the case is matched. And after that, you can put break or not. If you put break, then the interpreter will go to the end of the switch. But if you don't put break, it will go over the next case. And then you can also put a default, which is what's going to happen if none of the cases are matched. And I think this is it for this video. The next video I'm going to talk about loops. The next concept that I'm going to talk about is loops. And a good way to think about a loop is a circle. So a loop is going to run until a condition is met or until the end of whatever you're looping arrives, let's say. So there's two fundamental ways to loop through things. One is to loop through an element, which is an array or a list or a tuple or a string or object values or keys. And whenever you get to the end of that, whatever you're looping, then the loop is going to end. And the other fundamental way is a while loop. And the while loop, you have to put a condition. And whenever that condition is met, the loop is going to end. So there are ways to do infinite loops. So for example, if you put while true, then the loop is never going to stop because the condition is never false. But usually what you want to do is put some sort of condition, and then that condition is going to break the loop whenever you want it. So in Python here in the left, I have this for element in numbers. And what this is going to do is going to replace, this numbers is this array here. And this element is going to be the elements inside of the array one by one. So it's going to start at the element 1 and then go to 2 and so on and so forth. And the equivalent for that on JavaScript would be this code here. And what this code does is very similar to this one in Python. It's pretty much the same thing. It's going to loop through this array here, and it's going to, the value that you declare here becomes this 1 and 2 and 3 and so on and so forth. And then you have the while loop in Python in JavaScript. And then you have condition here, which is the length of this array. And then when this condition is met, it's going to stop the code. And here you have this I, and then it's increasing the I inside of the loop. So when I reaches 10, it closes the loop, stops the loop. And then in JavaScript, we have a different loop, which is a loop that allows you to go over object keys. And in Python, you also can loop through object keys, but then you have to use a method. And I don't want to talk about this now because I'm going to explain methods in future videos. But yeah, this is a different kind of loop in JavaScript. And then in both Python and JavaScript, we have this last kind of a loop here, which allows you to loop over a range of numbers. So in Python, whatever number you put here is going to start from 0, and then it's going to go until 1 before the number that you put here. So in this case, it would be 9 because the number is 10. So it goes from 0 to 9. You can also do like this, where you put an initial number and a final number, and then you put the step. And in this case, it's going to go from this number here, first number, which is 0, until 10, which is this number, in steps of 2. So it starts on 0, and then in the next iteration of the loop is going to be 2. The first number is going to be 2, and so on and so forth. If you don't put the step, then it goes one by one. And in JavaScript, it's pretty similar. You declare a variable here, and then you make it equal to whatever you want, and then you put a condition after the semicolon here, and then you increase, which is you increase by whatever you want, and this is the equivalent of step here. And these loops can also be used to access properties of arrays by something called index. So every array or string has indexes, and it's pretty much self-explanatory. So whatever position the element is it's gonna have its own index. So the first position is 0, so it starts with the index 0, and then after every position after that is gonna be +1. So first position is 0, the second position is 1, so on and so forth, until it gets to the last position. And the last position can be also be called by -1. So it can go from the last position until the first position by putting minus. So -1 is the last, and the -2 is 2 from the last, and so on and so forth. So going from the right to left, you use minus, starting from -1. And then you would put the name, in which this case is array, and then you access by square brackets, and then you put the number here, and this would be equivalent in the first iteration. This I would be 0, which you would give this element, which is 1, this array. And you can do the same thing in Python. So in this video, I'm not going to talk about I'm not going to highlight everything that is fundamental, because I noticed on the last one that it gets it's too many things to highlight, and my GPU is not strong enough for the editing software. So I'm going to talk about some of the things that are fundamental, and then the other things that I don't talk about, I'm going to highlight. So everything that you see on parentheses here is fundamental. So everything that has parentheses is fundamental. You're always going to have to write it. And these square brackets are also fundamental on the JavaScript side here. So you always have to write it. And inside of this last for loop here, the structure is not fundamental, but it is going to be very similar from application to application. So usually you're always going to declare a variable in the first one. The semicolon here is fundamental, so you're always going to have to put. The second element is going to be a condition. So it's pretty much you saying when you want the loop to stop. And the third element is going to be how many steps you want the loop to increase. Yeah. And I think that's it. The other So I couldn't highlight the things because my GPU is not strong enough, so I'm just going to talk about it instead. In Python here on the left side, the for, in the while, this for, and then are all fundamental. This symbol here at the end, these two dots at the end are fundamental on each part. What's going to change is this element, in which this case is going to be whatever, is going to be the parts of whatever you're looping through. So in this case, it's going to become 1 in the first iteration, then 2 in the second. I think I explained that. The numbers is going to change, which is the thing they're looping through. The condition here is going to change for the while loop. The element here is going to change, which is going to be the number that you're looping through. The range, this is going to change as well. In this case, it's 10, then element is going to be 0 in the first iteration, then it's going to be 1, and so on and so forth. In JavaScript here, the for is fundamental, the while, the for, and the for here are all fundamental. All the parentheses that you see, the parenthesis symbol is fundamental, the square brackets are fundamental. What's going to change is this let value, which can be const as well, can be const or let. The array is going to change, which is the thing that are looping through, and it's similar to this one, to the one in Python here that I'm highlighting. The condition here in the while loop is going to change depending on the application. The const property is going to change. The object is going to change. The in is fundamental. The off is fundamental here. And here the variable, the structure is going to be the same, but the variable is going to change depending on the application. The semicolon is going to be the same. The condition changes depending on how long you want the loop to go, and the step changes. So I think that's about it. See you in the next video. So in this video, I'm going to talk about ternary operators, and they are simply just a way to write if-else statements in a faster, cleaner way. So here I have this if-else statement, and if number is greater than 0 is going to console log cat, and else is going to console log Bob. And the equivalent of that is this expression here in the bottom, which is the ternary operator. So first you have the condition, then you have a question mark, then you have the code that is going to run if the condition is true, and then you have these 2 dots, and the code that is going to run if the condition is false. So it's like the 2 dots are equivalent to the else statement, and the question mark is equal to the if statement on the first condition. Python doesn't have any specific syntax for ternary operators, but you can achieve something similar with this expression here on top. And the only difference is that in Python, you put the code that is going to run first. So in this case, print cat is equivalent to console.log here, cat in the bottom. And then you put the condition after the if statement. So the 2 first expressions are switched on Python. And then you just use the same syntax you would use for if else. And the only difference is that you can do it like this when you want to write the conditions in only one line. So it's just a cleaner way to do it. So the last thing that I want to talk about in this video is this nullish coalescence operator, which is this double question mark. And the reason why this is useful is because this operator works as in a very similar way as this OR operator here. And the difference is if you use the OR operator, it's going to consider 0 as a false value. So that means if num here is equal to 0, the result of this operation is going to be console.log cat. But if you use the nullish coalescence operator, the result is going to be 0. And this happens because the OR operator considers 0 as a false value, and if you use the nullish coalescence, considers only undefined, null, and null as false values. So that's the biggest difference. And this is useful because in some cases you want the 0 value to count. For example, if you're using something related to currencies, then maybe you want the value to be $0. So in that case, you would use the nullish coalescence operator instead of the OR operator. And I have the example here, and you can see that when it console logs these values, the first one is 0, which I'm using the nullish coalescence operator, and the second one is 42 because I'm using the OR operator. So see you next video. So in this video, I'm going to talk about functions, and I'm going to briefly explain them. I'm going to talk more about them later when I talk about scope. So in Python here on the left, the def keyword is fundamental, and in the right in JavaScript the function is fundamental, and these are pretty much equivalent to each other. And then you have the parentheses are fundamental in both. In Python I have these 2 dots again, which is fundamental. In JavaScript you have the square brackets, which is fundamental, and then you have this return statement here, and this is optional on both languages. So the reason why functions are important and useful is that sometimes you have code that you want to run multiple times, but you don't want to write the code multiple times. So functions allow you to save time and save you from repeating yourself. So you can encapsulate the code inside of the function, and then after you do that, all you have to do is call the function, and every time you call the function, the code that is inside is going to run. So here in this example, I have 2 numbers here, and then I'm summing them and storing the value in the sum result, and then I'm summing them again. And instead of doing this, I can just call the function here. That's how you call the function. You just type the name of the function, and then you put the parentheses. And then if the function has arguments, which are these things inside of here, then you have to pass these arguments as well. And I'm going to explain more about this soon. So that's pretty much why functions are useful. In this case, it's not that different, but if you can imagine, if instead of summing this number here, I was doing a bunch of different operations, then I would have to repeat all of the code multiple different times, which would take a lot of space. And instead of doing that, I could just put here, encapsulate all the code inside of the function, and then just call the function whenever I want all that code to execute. And that's the main point of the function. So in order to explain arguments, I'm going to use an analogy of an arcade machine. So imagine I have an arcade machine, and depending on the way that you design the arcade machine, it's going to accept specific coins from different currencies, and it's going to give you an output. So imagine you have one of those machines that allows you to play basketball. So you put a coin into the machine, and then it gives you basketballs. So that's very similar to the way a function works. Depending on in which way you design the function, you're gonna make it so that it accepts certain coins, and based on those coins, it's gonna return some value. So this is the point of the return statement. This is like you're returning the basketballs based on the input that the function received. And the input are the arguments. So the arguments here on this analogy would be like the coins. And then you can make it so the function receives multiple different coins from different currencies, like dollar, euro, etc. So in this case would be A and B, so multiple different arguments. And each argument is separated by a comma here. And there's also another distinction, which is you can make it so the function accepts arguments with a default value. So that would be like accepting a coin with the value of true, and the value is predefined as true. So the reason why you do this is because in some situations you want the value to always be the same, or you want to be able to call the function without passing the value. So imagine here, instead of passing these two numbers, I just passed number here. It wouldn't work because this function is requiring two values, but I'm passing just one. But if I made b equals 10 here, this would be a keyword value, a keyword argument, which means that if in case I don't pass the argument, the value of b is going to be 10. So it's like a default value. And in Python, you have ways to pass. So in Python, I have ways to pass values in case you don't know how many values you're gonna need for the function, and you want to be able to allow people to pass an arbitrary number of values. You can use this asterisk here before the word, and usually this is represented with this word here, args. Asterisk args, and what this allows you to do is pass as many arguments as you want. So in this case, we're passing A and B, but if you do like this, you could pass A, B, C, or how many arguments you want. And this is useful because when you're calling the function, it allows you to have some flexibility in the way you call it. And the same thing happens here, but this one is for keyword arguments. So this allows you to pass as many arguments of this style here to the function, but it works pretty much in the same way. And the version of that in JavaScript is these special keyword arguments. So in JavaScript, when you write arguments inside of the function, it's going to represent the same as these asterisk args here that I just explained. But the limitation of this is that it doesn't accept keywords just like Python does with this thing here. So this, in JavaScript, you can only pass an arbitrary number of arguments and not keyword arguments. So another thing about functions is that you can pass another function as an argument, and this is called a callback function. So whenever you have an argument that you want to work as a function inside of another function, you are going to call that argument inside of the function, just like in the way that is written here. So here you have callback, and then inside of the callback, you're calling a function. So you're calling this function. And this can be whatever you want. So when you're calling this do something function here outside, you're going to pass a function to it. And then inside of the do something is going to call the function after it's done executing whatever code you have inside of the do something. And this is useful because a lot of times you have other things you want to call depending on the execution of the code of the main function. So it's exactly like it is here. You have this onComplete function, and then you're passing this function inside of the other function. And then inside of this function, you're calling this function here. And this is called a callback. And this is pretty similar in both JavaScript and Python, exactly the way that it is written here. So Python is on the left, JavaScript on the right. Another small nuance in Python is that you have this keyword lambda here. And what this keyword does is allows you to write a function in a simplified way without specifying a name of the function. And this is useful because a lot of the times you just want to write a function in a quick way without having to write this syntax here. So the lambda keyword allows you to do that. And then you pass the arguments right after you do lambda, and then you put this 2 points here, and then after that you put the code that you wanted to run. And the limitation of this is that you can't put a lot of complex code because then the syntax doesn't work. So it's only useful when you have short functions that you want to place. And the last thing that I want to talk about is the reason why I'm doing this video now, and it's because I want to explain methods in a future video, either in the next video or 2 videos from now. And methods are pretty much functions that come with the language. They are built-in functions from the language, and they allow you to perform a bunch of operations on different data structures like arrays, strings, objects, and things like that. And these methods are very useful, and you're gonna use them a lot of the times when you're doing things. So it's important to know them, and I'm gonna make a video explaining each method from each data structure, and I'm gonna show them side by side for Python and JavaScript and tell the difference. This one here is an example of a method in Python and in JavaScript map, which is applied on the myArray. But I'm going to talk more about this on the videos about methods. So see you next video. This video I'm going to talk about libraries and frameworks. So remember in the previous video where I spoke that data structure is a collection of logic gates, and people face the same problem a bunch of times. So they decided to create a concept that encapsulates the solution for the problem, and in that way it becomes easier to solve the problem next time because you don't have to rethink all the configuration of logic gates that are going to make the data structure. You start from the data structure directly. So the same thing happens on every programming language. People face the same problem a lot of times, and then they create a series of codes that solve the common problem, and they make that available for everybody to use. And that's called a library or a package. And when you have a collection of different libraries, it's called a framework. So a framework is just a solution for a more complex problem that involves a bunch of different libraries. Three famous frameworks in Python are Django, Flask, and FastAPI. And famous frameworks in JavaScript are React, Next.js, Angular, and Vue.js. And all these frameworks are used to build websites. So you can think about a programming language in the same way you think about a country. Is like a hive mind. And the more people build code for common solutions on the language, the more the language grows and the more useful it becomes. And that's one of the biggest reasons why Python and JavaScript are one of the biggest languages. Since most people use them, there's a lot of solutions on different libraries that were built for them. And that's what shapes the language. So that's a very important thing to know when you're building a product as well, because the more people code in that language, the easier it's going to be to hire, find people to hire, and things like that. And the way you install libraries in your computer to use on your own applications is by using something called a package manager. And in Python, the package manager is called pip, and in JavaScript it's called either npm or yarn. So JavaScript has 2 different package managers, and the newest one is yarn, so is the one that I recommend you to use, but they are pretty much the same thing. And then once you have those things in your computer, you can type commands on the command line or the terminal, and you install the packages that way. So this is the command prompt, and this is where you would type, or on this here, which is the terminal. And on the next video, I'm going to explain more how this thing works, how you're able to type something in the terminal and then it installs a library. I'm going to explain the connection there. For now, I'm going to continue to explain this further. I'm going to talk about Python first because it's easier to explain. So if you want to install a library, all I have to do is write pip install and then the name of the library if you have Python installed. And I'm going to talk more about the installation process in a future video. But yeah, something that I have to say is that you have to be careful on which libraries you install, because some of the libraries can have malicious code and you can get hacked. And obviously in the biggest libraries, this doesn't happen because they're really big, and then people would realize if that was happening because everyone uses them. But it is possible for that to happen, so you do have to be careful about that. And the other thing that I have to say about Python is that if you're using this IDE that I'm using now, it's called PyCharm, and you want to set up the Python interpreter for the IDE, you go on File, Settings, then Python Interpreter, and you just click on Add Interpreter and Add Local Interpreter. And then you're going to have several options here, but a really common thing to do is add this thing which is called a virtual environment, which you can see here. And in this case, I already have here, is going to be this file called VM. And the reason why you do that is because you can think about the system of libraries as being your house, and you can get a bunch of books and put all over your house, but that's a very disorganized thing to do, because then it's going to be hard for you to find specific books that you're looking for. So it's oftentimes much better to separate specific books about specific topics in each different room. So you have a room for fitness, a room for philosophy, and things like that. And then it becomes a lot easier for you to find the books. And it's the same thing here on when you're doing projects. It's much better to separate the code or the libraries that you use for each specific project on its own environment. And that's why virtual environments are useful. And then if you want to see the code, the source code of the libraries you download, you just go in the VM file in the lib. The scripts file is where the actual program that is going to interpret Python is at. You can see that you have the pip here, which is the package manager, and you have python.x, which is the thing that is executing their Python code. And to see the libraries, you just go in lib and site packages, and these are the libraries I have installed for this project here, which is not much. And then I'm probably gonna leave some code showing you a picture of the code on how to activate the virtual environment outside of if you're using VS Code or other IDEs. In JavaScript is very similar, but in JavaScript there is a difference where you can use two different commands. You can either use something that is called npm, or you can use yarn, and yarn is newer, so I think it's oftentimes better to use yarn, but there isn't too much of a difference between them. If you're gonna use npm, you would do npm init, and that is gonna initialize the file in your directory. And if you're using yarn, you also do yarn init. And then to install things, you would use npm install and then the name of the library or package. And if you're using yarn, you would put yarn add and the name of the package. And for removing a package in yarn, you use yarn remove, and npm use npm uninstall. So yarn init. And then after you do this command here, as you can see, it asks a bunch of questions that doesn't matter right now, but it creates this package.json file. And this file is pretty similar to the one here on Python VM. Is pretty much the same logic. So every time you install a package, it's going to show up in this file. And then if you want to remove as well, it shows up in this file. And then in Node.js is also going to create a folder called node modules. And the folder called node modules works exactly in the same way that VM does, where you can go on the node modules folder and it's going to have all the packages you installed. And then you can look at their source code by investigating that file. So here I downloaded a package called Axios, and then here you can see that I have node modules now, and then I have all these files here, and then here I have the Axios file, and this is the source code for the Axios. So if I want, I can search it up, this file. And if you want to learn more about the Python interpreter, the name of one is V8 engine, and I'm probably going to make more videos about this in the future, but this is a more advanced topic, so I'm going to leave that for the future. In next video, I'm going to explain environment variables, which are related to the installation and the way that these commands work, which are pretty much the reason why these commands work. I'm going to explain why by you typing this stuff on the terminal, it actually makes the installation for you. So see you next video. This video, I'm going to explain something I wish I knew when I was starting out. So let's say I'm going to open up the command prompt, just open the search here, put command, and open this. And then if I type Python here, it's going to initialize Python. And to exit this, I press Ctrl C. And the question that I had was, how the hell the computer knows what Python means? And in order to explain that, I'm going to use this thing here. So the operational system is like the brain of your computer, and it is the thing that connects the hardware to all the processes going on. So processes are like things like web browser, the clock, the VS Code, Python script. So anything you run on the computer essentially is run by the operational system. The operational system is connected to the hardware. And this includes the command line. So the command line has a direct access to the operational system. And it's kind of like the program you use to communicate with the operational system. And the command line has a bunch of commands built in to it that come with the command line, but it is possible to add custom commands to it if you want. And the way you do that, you just go into search, just press var, and this thing is going to show up here. Added the system environment variables. Then you go into environment variables, and then here you can add variables to the system or to the user. Just go in path and you click on edit, and then you have all these paths here. So if I go to one of these paths, so you can see here I have Node.js and I'm on the file, and I have this executable here. So this makes it so that the computer is going to execute whatever executable has on this file with the name that you type there. So if I type node in the command line, it's going to recognize because it is actually calling this file. And the way you can do that is because I put the path of this file in the environment variables. And you can essentially do this with anything you want. So the thing is, it has to be an executable, so it has to be a code that you compile and transforms it into an executable, and then you can put the path of the code to the system environment variables, and then every time you type that word, whatever you name the executable, then whatever code you have as the executable is going to run. And every programming language, not every programming language, but most of them have a way to communicate with the system. So there are ways to create files by typing code on programming languages by accessing the system processes, which you can do in Python and in JavaScript. So people create this code, people create a bunch of code, and then they encapsulate all the code into the executable of the word. And that's how, in a lot of ways, you can type Python and then some arguments, and then it's going to create a bunch of files. Because under the hood, what it's doing is the code is communicating with the operational system, and the operational system is creating the files that the code is telling it to create. So that's how the commands that I explained in the previous video of npm install and yarn work under the hood. Is all this, the environment variables of the system contain the path, and the path is an executable, and the executable contains a bunch of code that tells the operational system what the command is going to do. So see you next video. I'm going to give a very brief explanation of what regex is, because some string methods use them. So it's a special syntax that allows you to search for patterns in strings. In JavaScript, you can use the backslashes like it is here, or you can create this class, which I'm going to explain in a future video. And in Python, you can use the library, whatever you say that, and it's pretty much the same thing in both Python and JavaScript. The most common use cases are for validating input, like an email form. The other most common use case is to clean and preprocess data, and one example would be extracting information from poker hands. So poker hands are pretty much text files, and then you can parse the text file based on these patterns and extract the information in order to be able to analyze your own game and create software around that. And the other most common use case is for search engines like Google or DuckDuckGo. I'm going to share now a picture of the most used patterns in regex. So the way that it works, you can put these patterns inside of the backslashes, and whatever matches that pattern inside of the text or string that you're analyzing is going to be captured by the regex. And the last thing that I want to talk about is the spread operator in JavaScript, and it works pretty much in the same way that the asterisk operator works in Python. If you haven't seen the video about functions, then go watch that so you can understand. But it's pretty much the same thing. It allows you to write an iterable or spread the elements of the iterable using only the keyword of the iterable. In this case, it would be an array, and the 3 dots before that. So here I have this array, and then I'm passing all the elements inside of this array to this other one. And the advantage of this is that I don't have to write every single element. I can just write these 3 dots and then the name of the array, and then I have all the elements. This is usually useful for creating arrays like this that contain other arrays, or for passing arguments to a function. In this video, I'm going to talk about methods. And methods are just functions that come with the language, and they're useful to solve common problems. And it's pretty much code that people built before, and you can use the function if you know the function name and to perform specific operations. As I was making this video, I realized that there are too many methods, so I'm going to split these into 3 different videos. And on this one, I'm going to talk about array methods. In the next one is going to be about string methods, and the third one is going to be about object methods. And the way that I'm going to structure this, I'm going to separate into different clips. Each clip I'm going to explain one method in JavaScript, and then I'm going to show the similar version on Python, and I'm going to order them based on the ones that are the most similar to the least similar. And from the ones that are most similar, I'm going to pick the ones that I think that are most useful first. So it's going to start from the most similar and most useful out of the ones that are most similar, and then it's going to go to the ones that are least similar and most useful, and so on and so forth, until it gets to the ones that the method doesn't exist on either one of the languages. And I'm not going to show all the methods from both of the languages. These are just the vast majority of them that I think you're going to see all the time. And some of them I'm not going to show as well, because I didn't talk about classes yet. And specifically in the part of the object ones, I left a bunch of them out of it because I'm going to have to talk about classes to explain them. So I decided to just not talk about them now. So next, I'm going to put all the clips together, and that's what you're going to see for the rest of the video for array methods. And the same, it's going to be the same thing for the video on strings and the video on objects. The map map method in JavaScript applies a function to each element of an array and returns a shallow copy of the array. And in this case, the x is the argument that the function receives, but it can be whatever you want. You can write whatever you want as the argument here, and then apply whatever logic you want. And in Python, it's very similar, but the only difference is that Python, you call a function, and then you pass another function inside of this map function here. And as the second argument, you pass whatever iterable you're trying to apply the function to. And the result of this is an iterable as well. So you have to apply the list function after it to get the modify list at the end. So the filter method in JavaScript accepts a callback function. And then depending on whatever condition you put inside of the callback function, is going to test each element of the array. And if the elements pass the condition, then they're going to be included in the resulting array, which is going to be a shallow copy of the original one. And the keyword here can be anything that you want. In this case, I just did two different words. So you see that whatever you put here is going to become each element of the array on each iteration, and then it's going to loop through all of these different elements. So this word is going to become the items of the array through each iteration, and it's going to go over the entire array. And in Python, the functionality is pretty much the same, but the difference is that you call a function, and then inside of the function you pass another function as an argument, and then you pass the array as an argument inside of the function. So you're not calling the method on the array, you're passing the array as an argument to a function. And then this function returns an iterable, and to turn that iterable into a list, you call the list method in Python, and then that results in the filter version of the initial list. The reverse method in JavaScript is just like the name says. It reverses an array, and it changes the original array, and then it returns a reference to the array. And in Python, it is exactly the same thing, and even the names are the same. So it's pretty much the same method. The index of method in JavaScript returns the first index at which a given element can be found in an array, or -1 if the element doesn't exist in the array. And the equivalent for this is index in Python, and it's pretty much exactly the same. The name of this method is called concat, and it joins two different arrays. The similar version of this is extend in Python, and the first elements of the resulting array are going to be the elements that are in the array that concat is being called on. And the difference between the JavaScript version and the Python version is that in JavaScript, it creates a copy of the arrays and it doesn't modify the original arrays, but in Python, it does modify the original arrays. If you want one that is exactly the same, you can use a library called numpy, and then you use the np.concatenate on the arrays, and it's going to be pretty much the same, but then you have to use the library numpy. In JavaScript, the reduce method tries to reduce an array into a single value, and it accepts a callback function and then an optional second argument, which is a value. And this callback function accepts two different arguments. One is an accumulator and the other is a current value. And the way that it works is in the first iteration of the loop, you can think about this as being a loop. And in the first iteration of the loop, the accumulator is going to have the value of the first element of the array, the element at the 0 index. And then the current value is going to be the second element of the array. And then it's going to apply the logic of the function, and then it's going to store the resulting value of the operations of the function into the accumulator. And then it's going to do this over and over and again for all the other elements of the array. So the accumulator only changes in relationship to whatever logic you put inside of the function, and the current value goes sequentially in the iterations of the loop. And if you pass this second argument here, then instead of the accumulator starting as the first element of the array, it's going to start as whatever element you pass here, in which case is 0. And in Python, it's pretty similar. The only difference is that you call a function, and then inside of this function, you pass another function. In this case, x would be the accumulator and y would be the current value. And then you pass the array that you want to apply the reduce to. And it works pretty much the same way. And Python doesn't have a built-in function for this, so you have to use a library called functools. And the functools is a built-in library for Python. In JavaScript, the slice method does as it says. It slices an array and returns a shallow copy of it. The first argument that it receives is where the slicing is going to start, and the second element is where the slicing is going to end. If you don't put the second element, then it's going to slice from the starting point up until the end of the array. So it's going to return from that point up until the end of the array a new array that is a shallow copy of the original one. In this example here, would start at the index 2, which is camel, and then return the remainder of the array, which is this output here. And if you specify the ending point, then the ending point is not included. So in this case would be the element at the index 4, in which this case is elephant, but then it doesn't include that on the resulting array. And in Python, it's pretty similar, but Python doesn't have a built-in function for this. So you have to use this slice function, which returns a slice object, and then you have to use that as the index in the original array in order to get the new array that is a slice version of the original one. The only difference in Python is that if you don't specify the second element in this function, then it's going to return the remainder of the array from right to left. So in this case, if you didn't specify 3 here and the starting at index was 2, then it would return 3, 2, and 1 1 instead of returning 3, 4, and 5 as you would on JavaScript. The flat method in JavaScript reduces the level of nested arrays. So you can put arrays inside of other arrays, and when you use the flat method, it's just like it says, it's going to remove one level of array instead of the other array. So in this example, you have the array 3 and 4 instead of the main array, and if you use flat, it becomes only one array, a single array. The default is to flatten by one level, but if you pass an argument, you can decide how many levels you want to flat. So in this case, you can see that this array is nested more times. So you pass the 2 as an argument and only flattens 2 levels, which means that it's gonna still be nested at the end. And if you didn't put an argument here, you would only flatten by one level. And in Python doesn't have a built-in function for this, so you have to use a library called NumPy. And then if you're using NumPy, then you can call the flatten method, and it's gonna work in the same way that JavaScript does. The for each element in JavaScript accepts a callback function and then performs whatever logic you put inside of the callback function on each element of the array. And this arrow here is just another way to write, just another syntax for writing function. And the difference between the for each and the map methods is that the for each changes the original array, but the map method creates a shallow copy of it, so it doesn't change the original. And in Python, it doesn't have an equivalent for this, but you can achieve a similar thing by doing a normal for loop. And you can also use the enumerate function, which allows you to get the index of the element as long as the element, and then you can access the element of the array by putting the name and using the square bracket operator and putting the index inside of it to access the element, and then modifying based on whatever condition or whatever logic you place here. And the enumerate goes here as a function and accepts the array that you want to loop over. The sort method in JavaScript accepts a callback function and then compares the elements of an array based on that callback function and sorts the array based on that. And the default way of comparing is by first converting the elements into strings and then getting the UTF-16 code unit values from the strings and then comparing based on that value. And what a UTF-16 code unit is just a protocol of a representation of that data type, which in this case is strings, into 16 bits. And that's the reason why the outcome here isn't what you would expect in both of these cases. So here you would expect that it would go from 1 to this highest value here, but it doesn't happen because you're comparing the UTF-16 code units and not the values themselves. And here in Python it's pretty similar but not the same. Instead of calling the function in an array, you call it as a function and then you pass the array into the function, and then there is the option to pass a function. You can either pass reverse equals true, which is going to reverse sort the array, or you can pass a key function, which is any function that is going to return a value that is going to allow you to compare two different elements of the array. In this case, I'm using the len function, which is used to get the length of a string. So this is going to return the length of each element of this array, and then it's going to compare them, and this is going to sort the array based on that. The sum method in JavaScript is similar to the every method. It receives a callback function, and then it tests every single element of the array against that whatever logic you put inside of the callback function. And the only difference is that if any of the elements returns true, then the result of the operation returns true. And the similar thing in Python is the method any, which is different because it tests to see whether any of the elements is true. And in JavaScript, you can test against other conditions depending on how we structure the function. So Python is more limited than JavaScript in that sense. The name of this method is every, and it accepts a callback function and then tests every element of the array to see if it passes tests that is implemented in the callback function. And the similar function to this in Python is called all, but the difference is in Python you pass an iterable instead of a callback function. So in JavaScript you have more flexibility because you can test for more things, and in Python it only tests to see if all the elements inside of the array are true or false. The name of this method is copy within, and the way that it works is you get a range from the array and you make a copy of that range, and then you replace the elements in the same array with the copy of the range you selected. So the first argument in the function is going to be the starting position of the index that the copy is going to be done, and the second and third element are the ranges that you are going to copy. So in this case, it's go from the index 3 to 4, so that makes it so that only gets the value d here on this array, and it's going to make the replacement starting from index 0, which in this case is a. So it's going to replace a with d. If you don't put the second argument, then it's going to start at the starting argument, which is the index string in this case, and it's gonna go until the end of the array. So in this case, we would take D and D and E, and it would replace A and B with D and E because it starts at index 0. The other thing that I want to talk about is that this creates a shallow copy, and the difference between a shallow copy and a deep copy is that a shallow copy, if you have objects inside of the array, then the shallow copy is only gonna create references to the same objects. It's not gonna create new objects. And if you had a deep copy, then it would create new objects as well. And the version in Python of this is the method called copy, but it's not the same thing. It's very similar, but not the same. So copy creates a shallow copy of the entire list, and it doesn't modify the list at all. So there is no similar version in Python. You can achieve the same thing, but then it would take more steps. The flat map method in JavaScript is just like the name says. It first applies the flat function, and then it applies the map function. And both the flat and map functions are built-in methods from JavaScript, and Python doesn't have an equivalent for this. The splice method in JavaScript is used to either add, remove, or replace elements of an array. The first argument that it receives is the index where the replacement or deletion is going to start. The second argument that it receives is the deletion count, or how many items it's going to delete. And the other arguments that it receives is the elements that are either going to replace the older ones or they're going to be added to the array. If the deletion count is 0, then it adds the elements, and if the deletion count is more than 0, then it's going to delete some elements and add the remainder elements that you pass as argument. And if you don't pass a second argument, then it's just going to delete the remainder of the array starting from the index that you pass as the first argument. Python doesn't have a direct equivalent for this, but you can use the square brackets and this two dots operator to get slices from the original array or string, and then you can concatenate them. But it takes extra steps, so it's not a directly equivalent. So Python doesn't have a built-in method for this. The reduce write method in JavaScript is exactly the same as the reduce method, but it starts from right to left instead of left to right, but it's pretty much the same thing. And Python doesn't have an equivalent for this. The last index of method in JavaScript returns the last index that an element can be found in an array, or -1 if the element is not present in the array, and Python doesn't have an equivalent function for this. This video is going to be a sequence of clips showing string methods in both JavaScript and Python, and I'm going to show first the ones that I think are the most similar, and then last the ones that I think that are the least similar. And out of the ones that are the most similar, I'm going to show the ones that I think that are most useful first, and then the ones that are least useful later. In JavaScript, you can convert an entire string to lowercase by using the toLowerCase method, and in Python, you can use the lower method to achieve the same thing. In JavaScript, you can convert an entire string to uppercase by using the toUpperCase method, and in Python, you can do the same thing by using the upper method. In JavaScript, you can convert an object to a string by using the toString method, and in Python, you can achieve the same thing by using the string function, and they work exactly the same way. In JavaScript, you can use the string method to remove white spaces from both the start and the end of a string, and it doesn't change the original string, it just returns a new one. In Python, you have an equivalent method for this, which is the strip method, and it does exactly the same thing. In JavaScript, you can remove the white spaces from the start of a string by using the trim start method, and in Python you can achieve exactly the same thing by using the lstrip method. In JavaScript, you can use the trim end method in order to remove the white space from the end of a string, and in Python you can achieve the same thing by using the rstrip method, and they work exactly the same way. The split method in JavaScript allows you to turn a string into a list of strings based on a pattern, and the pattern is whatever string you pass as the argument to the split. So the original string is going to be split by the pattern you pass as an argument, and you're going to receive the list of the words that were separated by the pattern. And in Python, it works exactly the same way. You also have the split method, even the syntax is the same. The pad start method in JavaScript allows you to insert a string at the beginning of another string, and the first argument that it receives is the amount of times that the new string is going to be inserted. And in Python, we have a very similar method, which is called ljust, that does pretty much exactly the same thing. The pad end method in JavaScript allows you to pad the end of one string with another string, and the first argument that it receives is the amount of times that the new string is going to be inserted. And in Python, we have a method called rjust that it works pretty much exactly in the same way. In JavaScript, you can replace one string for another by using the replace method. In this case, it's replacing dog with monkey, and it's calling the method on this p string here. So if you pass a text, it's going to replace all the instances where the first string occurs with the second one, the second argument. And if you pass a regex, it's only going to replace the first instance. In Python, you have pretty much the same method, but in Python, they replace only basically replaces the first instance. And then if you want to replace multiple instances, you have to use the re library and the sub method of the re library, or you can use replace in a loop as well, and that works as well. So they work pretty much on the same way. The starts with method in JavaScript allows you to check if a string starts with another string. It returns true if it does and false if it doesn't. And it can also pass the starting position as the second argument of the function. Python, it works exactly the same way. The only difference is the way that you write it, where with the W in lowercase. The ends with method in JavaScript allows you to see if a string ends with the same characters of another string, and it returns true if it does and returns false if it doesn't. And in Python, it works exactly the same way. The normalize method in JavaScript allows you to return the Unicode normalization of a string, and you can pass what protocol you want to use as an argument. Here are examples of different protocols. And in Python, it's pretty much the same thing, but you have to use a library called Unicode data, and then you call normalize on that. But the function works in the same way as it does in JavaScript. The index of method in JavaScript is used to get the index of a string instead of another string. And you can pass an optional second argument, and what that will do is return the index of the first occurrence greater than the number you pass as the second argument. And in Python, we have the method index, which works exactly the same way as the index of in JavaScript. In JavaScript, the last index of method returns the last index that a string is found in another string. And you can pass an optional second argument, and if you do that, then it's going to return the last index of the string equal to or less than the number you pass as the second argument. And in Python, the version for that is this rIndex method, and it works pretty much exactly in the same way. The charCodeAt method in Python allows you to get this UTF-16 code unit value of a character instead of a string based on the index. So you pass the index as an argument, and then it returns the UTF-16 code unit value. And in Python, you have the ORD function, which it works pretty much in the same way. The only difference is that is a function and not a method, and in JavaScript, it is a method. The concat method in JavaScript allows you to concatenate strings into another string, and Python doesn't have an equivalent for this, but very effective thing you can do is to use this f before a string, and every time you do that, then you can use curly braces inside of the string in order to declare a variable. Here I'm declaring the variable s1, which is this hello, and the variable s2, which is this world, and I'm achieving the same effect that I achieve here in JavaScript using concat on these two strings and getting hello world here at the end. The includes method in JavaScript is used to check if a string is included in another string, and it returns true or false, and it is case sensitive. In Python, the version of this is find, the find method, but it's not exactly the same because find returns an index and not true or false. And if the word is not included, then it's going to return -1. The slice method in JavaScript allows you to slice a string, and the first argument that it receives determines the index where the slicing is going to start. The second argument determines the index where the slicing is going to end. If you don't put the second argument, then it's just going to slice from the first argument, from the first index until the end, and it doesn't change the original string, it just returns a new one. Python doesn't have an equivalent for this, but you can use the square brackets, and you can use this two-dot operator in order to separate the start index and the end index. And if you use another two-dot operator, then you can specify a step, which is the amount or the number of indices that are going to be skipped between characters. The substring method in JavaScript allows you to get part of a string by specifying in the start index and the end index. So the start index is the first argument, the end is the second argument. And if you don't specify the second argument, then you just get the remainder of the index is starting from the first argument. And the second argument is not included, the end is not included. So in this case, you wouldn't get the character at position 3 because you're passing the argument as 3. If you want to include the character 3, then you pass 4. Python doesn't have an equivalent for this, but you can use the square brackets, and then you can use the two-dot operator inside of the square bracket. The left number of the two-dot operator is going to be the start index, and the right number is going to be the ending index. And then you can also specify a step by putting another two dots and a number on the right, and that's going to determine the amount of indices that are going to be skipped between characters. In JavaScript, you can use the search method to search a string or a regex pattern, and the return is going to be whatever gets matched. And in Python, you don't have a similar built-in function, but you can use the re library and the search method of the re library in order to achieve a similar effect. And after you do that, you're going to receive a match object, and you can call the group methods or group function on the match object, and you're going to get the pattern that was matched. The match method in JavaScript allows you to match a string against a regular expression. And if you have the G flag on, which is is the thing that I'm highlighting now, is going to return all the matches that it finds in an array. And if you don't put the G flag, then it only returns the first match. And if it doesn't find any matches, it's going to return null in both cases. In Python, there's a similar pattern called search from the read library, but it's not the same thing because it returns a match object. And then you can get this index, the first index of the first match if you call the start method, the start function of the match object. And you can get the last index of the first match if you call the end method. And if you call the group method, then it's going to return the first matched object from the string. So it's not quite the same because they don't return the same thing. The match all method in JavaScript allows you to match a string against a regular expression, and it returns an iterator of all the matches that it finds. And in Python, there is a similar method called findIter of the read library that also returns an iterator of all the matches that it finds on the string. And to print the matches or to get the matches, you have to call the group function on the match that it gets from the iterator, from the objects instead of the iterator. The replace all method in JavaScript allows you to replace all patterns of a string with a replacement. So you pass the pattern as a string or as a regex as the first argument to be replaced, and then the second argument is going to be the replacement. And if you're using replace all, you have to pass the G flag when you're using the regex. And Python doesn't have a similar method for this, but you can use the read library and then use the sub method of the read library to achieve the same effect, or you can use replace on a loop. In JavaScript, you have something that is called the raw method, and is used to get the raw form of the string without the escape sequences. And escape sequences are some sort of actions that you can specify to the computer. For example, you can write \n, and that will make the computer go to the new line. But if you use the raw form, then it's gonna return to you \n instead of going to the new line. And Python doesn't have a similar method for this, but you can use the R prefix on the string, and you're gonna achieve the same thing. The from char code in JavaScript allows you to create a string from specified sequences of UTF-16 code unit values. And in Python, you have a similar method, which is this char here that I'm highlighting now, but it's not the same because the char only converts one character at a time. So you have to use an algorithm to convert multiple characters. The from code point method in JavaScript allows you to get a string based on a sequence of code point values. And Python doesn't have an equivalent for this, but you can use this module called unichar and create this algorithm here in order to achieve the same effect. In JavaScript, the code point at method allows you to get the Unicode code point of a value based on the index. So you call a method in a string, and then you pass the index, and then it returns the Unicode code point value of that character. And in Python, there's a similar thing, but you have to import the library called Unicode data, and then you call this function here. So this is an example of how you would use that, and it's pretty much the same thing as it is in JavaScript. In JavaScript, you can repeat a string multiple times by using the repeat method, and the numbers of times that the string is going to be repeated is decided when you pass the number as the argument here. So in this case, it would be 27 times because the argument is 27. Python doesn't have a similar method for this, but you can achieve a similar effect by just multiplying the string by the amount of times that you want the string to be repeated. Local compare method in JavaScript returns a number that indicates whether a reference string is the same or comes before or after in sort order from another string based on a specific language. And you can also pass optional arguments which allow you to select things like case sensitivity, and the return values that it gives are either negative when the reference string comes before the compare string, or positive when the reference string comes after the reference string, or 0 if they are equal. And this can be useful if you want to sort an array, for example, based on a specific language like French. So in this case, you have this array with these letters, and then you're calling local compare in the sort method, and you're sorting the array based on the French language and ignoring punctuation. And Python doesn't have an equivalent function for this. The center method in Python is going to center align a string based on another string or character that you pass as the second argument of the method, and the first argument will be how many times you want the string to be padded on both the left and right simultaneously. So here in this case, you have the string hello, and then after applying the method with the number 10 and this symbol here, you get this output of this new string. JavaScript doesn't have an equivalent method for this. JavaScript, different languages have different case mappings. So for example, English, French, and German can have different case mappings, and you can use the cholocal lowercase method to convert the string to lowercase based on that specific mapping from each language. And Python doesn't have an equivalent method. method for this. JavaScript, you can have different case mappings based on different languages. So for example, English, French, and German can have different case mappings. And you can use the toLocal uppercase method in order to convert a string to uppercase based on a specific case mapping from each language. Python doesn't have an equivalent method for this. The char_add method in JavaScript receives a number, which is the index, and then it returns whatever character is at that index on the string that the method is being called upon. In Python, doesn't have a direct equivalent for this, but you can use the square brackets to do the same thing. And then inside of the square brackets, you pass the index, and then it also returns the character respective to that index on the string. So in Python, you don't have a built-in method, but you can use the square brackets operator to achieve the same thing. JavaScript, you can initialize a string as an object, as is written here in the first line. And in case you do that, you cannot get the normal value of the string by calling the value of method on that object. And Python doesn't have an equivalent method for this. In this video, I'm going to talk about object methods for both Python and JavaScript that I think are the most useful. In JavaScript, the entries method from the object built-in class returns a list of lists of key value pairs from an object, and it converts the keys into strings. So in this case, you have A and B as the keys, but it returns a string of A and a string of B instead. And after you do that, you can use this loop here in order to get the key value pairs and do whatever you want with it. In Python, we have a very similar method, which is called items, and it does pretty much exactly the same thing, but the difference is you have to use the list function on it after, and that's going to give you a list of tuples of the key value pairs from an object. And it also doesn't convert the keys into strings necessarily, but besides that, it works exactly on the same way. In JavaScript, you can use the values method from the object built-in class in order to get the values of an object. So you pass the object as an argument, and then you're going to get an array of values from that object. In Python, you can achieve exactly the same thing by calling the values method in a dictionary, and it does pretty much the same thing. In JavaScript, you can use the fromEntries method from the object class to convert a list of lists into an object, and in Python, you can do the same thing by using the dict function, and it achieves exactly the same result. In JavaScript, you can use the keys method from the object built-in class in order to get an array of the keys of an object, and these keys are converted to strings. And the way that the keys are selected is you pass an object as an argument to the method, and then it's going to return the array of keys from that object. In Python, you can achieve the same thing by using the keys method on the dictionary, and it does exactly the same thing. The only difference is that it doesn't convert the keys into strings. In JavaScript, the assign method from the object class, that is a built-in class from JavaScript, is used to update a target object with a source object. So in this case, I have here the target and the source. The target is the first argument of the method, and the source is the second argument. And then what it's going to do is going to add all the key value pairs from the source into the target. If they have the same key, the value from the key from the target is going to be updated with the value from the key from the source. In Python, we have a very similar method, which is called update, and it does pretty much exactly the same thing. The only difference between these two is that the update method in Python is a built-in method for dictionaries, and in JavaScript, you have to use this object class, which is a built-in class from JavaScript, and then call the method. But besides that, they are pretty much the same. So in this video, I'm going to talk about the concept of scopes in programming, and in order to do that, I'm going to use the analogy of a city, a neighborhood, and a house. So in this analogy, the city would be the program, the entire program, the neighborhood would be the file, and the houses would be the functions inside of the file. So imagine you have a couple of packages inside of your house, and you have some packages that some people throw in the street. So in this case, if you are inside of a house, if you're the owner of the house, then you have access to not only the packages that are inside of your house, but also the packages that are outside on the streets. But the other way around is not true. If someone outside of their house wants to get into your house, they're gonna either need the keys, or obviously that would be against the law. And the same principle applies in programming, where in this case the house would be the function. So the function has access to variables outside of the function on the bigger scope, but the other way around isn't true. The global scope, or the scope that is outside of the function, which is the neighborhood, doesn't have access to the variables inside of the house. So it's the same structure that determines the organization of ownership of houses and the structure of cities and neighborhoods that dictates these differences in different scopes inside of a files and inside of the whole program. And there are other names for this, like you have global scope, then you have local scope, and then you have namespaces, and all these different names are analogous to different representations of these levels of abstraction that I'm talking about. Or so, for example, the house would be the local scope, and then the city would be the global scope, and then you have other scopes like built-in that encapsulate everything. So to continue in this analogy, the postman would be like the execution of the program, and it goes around the city delivering packages. So if you want the postman to get inside of your house to deliver a package, you have to specify that. That would be the equivalent of passing a variable to a function, or using a global variable inside of a function. That's like inviting the postman inside of your house. But usually the postman is only gonna deliver the packages, and then whatever happens in the house is up to the owner. And one thing you can't do is, for example, demand that the postman deliver packages for you that you didn't put on the post office. And the reason why is simple, because let's say you're not inside of your house, then there's no way for the postman to know what kind of package you want to be delivered, because he doesn't have access to your house. So he only has access to the global scope, which in this case would be the city and the post office. And because of that, if you try to tell him to deliver a package that is inside of your house and you don't make it available to him, he's not going to be able to deliver. And it's the same thing on programming. If you try to access a local variable from inside of the global scope, you're not going to be able to do that, because you only have access to the variables going from the most inside layer, which would be the house, to the most outside layer, which would be the city. So another analogy you can use is with books and libraries. So you can imagine that each book is a module, and then inside of the library you have a section, and that section is a namespace. So let's say a category like physics or economics or things like that. And then the whole library would be the program, the sections would be the namespaces, and the books would be each module. And the reason why this is useful is because of this thing that I have here, which is that sometimes when you're building a big application, you're going to use several different libraries from different people. And then there might be the case where they decided to make a variable with the same name. So in this case would be the variable a, and one namespace, one library decided to give a the value of 2, and the other one decided to give a the value of 5. So this can be a problem if you're running the program, because you may override different variables accidentally, and you don't want that. So in order to prevent that from happening, you have this thing that is called namespace, which allows you to attach the name of variables to something that is bigger, which is the namespace. And then that prevents these collisions from different names in different variables from different libraries. So another thing that is worth mentioning is that the notion of scope is the same in all languages, so it's a fundamental principle. But something that changes from language to language is that the layers of abstraction. So some languages decide to call a neighborhood for a certain amount of houses, but then other languages don't. So let's say you have 10 different houses, and then in one city that would be considered a neighborhood, but in another city that is not considered a neighborhood yet because it's too small. But the houses stay the same, and the houses in that analogy would be, or the houses of the notion of this space is the same. The only thing that changes is the layer of abstraction that people decide to put on the different amount of houses, and the structure that is going to be determined by that through the analogy of the postman and the way that he is going to deliver the packages inside of the house. So in Python, we have a special keyword that is called global, and that keyword allows you to make a local variable have global scope. So it gives access of the variable to the entire program. And in JavaScript, you have something that is called the window object, which is a global object. And you also have local storage and session storage that are both global objects as well. Common use cases of the window is to get the screen size, the position of the mouse, and the location of the user. And the use case for local storage is to store key value pairs usually. And you also have something that is called a cookie, but the cookie is not a global object. It's just a way to store information in the user's computer that the server has access to. And I'm not going to talk too much about this now because it's not the point of the video. So I think that's about it. And the next video, I'm going to talk about the this and the self keyword for both Python and JavaScript. This video, I'm going to talk about the this and the self keyword in both Python and JavaScript. And what these keywords do is they become whatever calls them. So in this example I have here, I have the person object calling this say name function. So the best way to imagine is as if the person substitutes the this keyword and becomes it, because it is what is calling it. And once that happens, the result is going to be John, because the person has the key name of the value John. But in this example here in the bottom, this doesn't happen. And the reason why is because in here you're making the value of greet equals to this person true dot say name, and then you're calling this function later, which makes it have a different scope by the time you call it. So a good illustration of what it is happening here is that it's as if you're calling the function like this on the scope outside on this situation here. So in this first situation, it's like you're calling the function from inside of the person object, but in the second situation here is like you're calling the function from outside of the person object. And because you're calling the function from outside, this keyword becomes the whatever scope is on outside of the person true, in which this case is the global scope. So here it would be like the global calling the attribute name in the global scope. But since the global scope doesn't have the attribute name, then it returns undefined. And the way to prevent this is to use this keyword in JavaScript, which is called bind. And what this allows you to do is to make the function have whatever value that you would have by the time you declare this, which would make it be acting the same way that it was on this situation here. So I have another example here just to clarify this more, because it is a very difficult concept to understand in the beginning. So in this example, you have a function inside of this function, say name from the previous example. And what is going to happen here is the same thing that happened before, where the second this keyword is going to be undefined and the first is going to be John. And the reason why this happens is because when this function is being called here, this inner function, it is being called from inside of the say name here. So this keyword is going to become the scope of the say name function. And in the scope of the say name function, there is no attribute name. So in this case, it's going to return undefined. But outside of the scope, what is calling this keyword here is the object. And this is going to become the object. And then the object has the attribute of name, which is John. So it returns John. And then you can do the same thing with the bind here to bind the value of this to the scope that is outside of this say name, that is outside of this inner function scope, which is the object to scope. Another thing that I want to mention is that you can use this arrow syntax to declare a function, and that would be pretty much equivalent to writing like this. So it does the same thing, it declares the function, but the difference is on the value of this when you use the arrow syntax, and it's going to be different in the way that when you use the arrow syntax, the this keyword is going to become whatever is on the scope that is one level above the thing that called the function. So in the previous case, when you use the normal function syntax, the this keyword becomes the scope of the say name, which doesn't contain an attribute of name. But if you use the arrow function, then it's going to go one level above that. And one level above that is the scope of the object, which has the property of the name of John. So this keyword is going to become John in this case, because it becomes the object, because you're using the arrow syntax. And in Python, the self keyword is pretty much the same as it is in JavaScript with the this keyword, but in Python, you don't have this arrow syntax, but besides that, it works exactly in the same way. In this video, I'm going to talk about the under methods in Python, and in order to explain that, I'm going to have to briefly explain classes, but next video, I'm going to go more in depth on classes. And in Python, a dunder method is a function that has two underscores before and after the name inside of a class. So just the way that is written here, I'm going to put some pictures on the screen as well so you can see examples in the code. And in order to understand this, you have to understand these two different concepts here, and these concepts come from C++. So one of them is polymorphism and the other one is operator overloading. And what polymorphism is that in C++, when you declare functions, you have to specify the type of the function. So here I have SumFunc and the type is int, and then I have SumFunc and the type is float. And that's pretty much what polymorphism is. It allows you to declare the same function twice, but with different types. That's what people mean when they say polymorphism. And operator overloading is very similar to polymorphism, but it is for operators. So you're essentially doing the same thing you did here on the functions, but you're doing that with operators. And in Python, the under methods are the Python version of this operator overloading principle here. So in programming, the mathematical operations are not the same as they are in mathematics, because what is actually happening is the symbol of the mathematical operation is being translated into a series of instructions that allow the computer to add a bunch of different binary inputs together. So what is actually happening in the hardware structure is that bits are being moved from one register, for example here on the left, into this ALU, which is the arithmetic logic unit, and then is being moved to the other register on the right here, and then it's going back and forth between the two and doing a bunch of operations so we can add all the bits together. So this is what is happening when you put the plus or minus sign on the computer file, and it's not fundamentally different, but it is different than if you're doing just adding operations on mathematics, because the way that you think about it is different. So understanding this, you have to understand that all these operators, they come with predefined rules for adding different data types together. So for example, if you're going to add two different integers together, then it's going to be one set of instructions that is going to run. And if you're going to add two different floats together, it's going to be another set of instructions. And the problem with that is that if you have different classes that you created and you want to add them, then the built-in method is not going to support that, because the set of instructions doesn't allow that. But then you can use the operator overloading in order to be able to do that. And the best way to think about a class is as if an object and a function had a baby. So it's just an object with a bunch of functions. And every class has a special function, which is the construction function, which is the function that is going to run as soon as you initialize the object. And initializing an object is the same as calling a function, just like the way that it is here. So in this example, I have v1, and that initializes the vector, and then I have v2, which initializes another instance of the vector, and they both call this dunder method here init when they are being initialized, and they both have this dunder method add. And what this operator overloading allows you to do is to add one instance of this class with the other one. But if you didn't have this, then adding the two together wouldn't be possible. So I'm gonna explain more about classes in the next video, but this is just a superficial explanation so I can explain what the dunder method is. So see you next video. This video I'm gonna talk about classes in both Python and JavaScript, and I'm going to explain how prototypes work in JavaScript and what are the differences fundamentally between Python and JavaScript when it comes to classes. So a good way to think about a class is like a template. So if you imagine a stick figure, the stick figure can have multiple different variations of it, but the patterns are very similar because it follows a rule set. There's some definition that makes up what a stick figure is, and then from that definition you can have multiple different instances that are slightly different. And this is like what a class does. It creates a template from which you can create several different instances that are slightly different but have the same kind of structure. So the way that you write a class in JavaScript, this is recently implemented, but you can use the class keyword now. And before you had to use something that is called a prototype, which I'm going to explain soon. And in Python, you also use the class keyword. And in both languages, you need to have an uppercase letter. The first letter has to be uppercase. And then classes have something that is called a constructor function. And what this function allows you to do is to initialize the class with different attributes. So in Python, you pass the self keyword, and then you pass whatever attributes you want the class to have, and then you assign a value to those attributes as you initialize it. And in JavaScript, you use the this keyword, and you also do the same thing. So they're pretty similar in that way. And what this keyword does and the self keyword does is it makes it each instances of a class have different attributes depending on what values you pass to each instance, because of the whole scope thing that I mentioned on the previous video that I did. Another concept to understand about classes is the concept of inheritance. So every time you initialize a class and you make it equal to a variable, that variable is going to have access to all the functions of the class. So in this case, I'm initializing Joe and making it equal to the person, and then I'm calling the method speak. So let's say that I want to initialize another variable called Bob, and I want to make it equal to a person class. But the problem here is that I also want Bob to be able to write. So I want to add a function here in the person that gives Bob the ability to write, but I don't want John to have the ability to write. So in this case, I can't really change the class because that would also give the ability to write to John. So what I can do in this case is I can create another class, and I can name it teacher, and that this teacher class is going to inherit the person class. And the way that you do that is just use this extends keyword and then put the name of the original class, and then teacher is going to inherit the person's class, and then you put on the constructor all the methods, all the arguments that the new class is going to have, and then you use this super keyword and put all the arguments that the original class has, which is the person class, and then you initialize the extra arguments that the new class has, and you also put the extra functions that the new class is going to have. So in this case here, teacher not only has access to all the functions that person has access to, but it also has access to this additional function, which is write. So now instead of initializing Bob to a person, I can initialize Bob to a teacher, and now it's going to not only be able to speak, and it's also going to be able to write, but John still only has the ability to speak. In Python, this works in a very similar way. The only difference is the syntax here, where you call the super, and then you call the dunder method of init, and then you pass the arguments of the original function, and also you put the original function inside of the parentheses of the second function. And I'm not going to explain this syntax and the nuances of the syntax too much, because the point of the video is to allow you to understand more what are the fundamental differences in the way that the structure of the language works and the reason why they are different. So I'm going to take more time to explain this last concept because it's a little bit tricky, but every function in JavaScript has something that is called a prototype, and a prototype is just an object. So every time you write a function in JavaScript, it's as if the interpreter is going to put, or the compiler is going to put this prototype here and it's going to make it equal to an object, but you can't really see that when you're writing the code. It's done behind the scenes under the hood in the language, and every single function in JavaScript has this. And then what you can do is you can put functions inside of this prototype here. So what this is doing is making a function equal to say hello, making a key equal to say hello in this prototype, and making the value of the key equal to this function. So it's as if this is happening here. When you write this stuff here, you're doing this pretty much. And this allows you to make this function have methods. So, and this is pretty much what a class is, but it works fundamentally different than the way that it works in Python. And the way that you would do inheritance, that inheritance actually happens under the hood, is you have two different functions, and then these two different functions are going to have two different prototypes. So you make the prototype of one function equal to to an object that contains the prototype of the other function. So it's like you're linking the two prototypes through different objects. So in JavaScript, the concept of inheritance is more about connecting different functions through different objects. And the way that the class starts is through the function first, then inside of the function you have an object, and then through that object you're going to create the methods of the function. But in Python it works fundamentally different, where you have the object first, you create the object first, and in the moment you create the object, you also create the functions. So it's fundamentally different because JavaScript, everything is kind of more connected and it's more flexible, and in Python is more rigid, let's say. So in Python you create the object with the functions, and in JavaScript the object already exists inside of any function, and you're just connecting different functions through objects. So an analogy that I like to make is that JavaScript is kind of like a tree, where at the root of the tree you have the beginning function of the class, and then each function that is going to inherit from the beginning function is going to be one leaf of the tree. And that's how the inheritance of classes evolves. It creates this prototype chain from the leaf of the tree until the root of the tree. But in Python it's more like this Lego structure here, where you create a block, which is an object that has functions, and then the inheritance is you're putting other blocks on top of that block. So it's difficult to express, but it's more like Python is more rigid and connected like that, and JavaScript is more like a tree or a chain of prototypes, like a real chain. So JavaScript has more flexibility and Python is more rigid, and that's the fundamental differences between the way that classes work in JavaScript and in Python. So see you next video. A final thing that I wanted to mention here that I'm not going to talk about now, but maybe I'll make videos about this in the future, which is a more advanced concept, is the notion of composition versus object-oriented programming. And the reason why I want to say this is because studying this stuff about classes in Python and JavaScript made me realize that JavaScript favors more a composition approach and Python favors more an object-oriented approach. So I thought that it is worth mentioning this here in case you want to study on your own. So just look up, there are a bunch of videos about composition versus object-oriented programming, and I think it's a concept that is worth looking for. So see you next video. A decorator is a function that wraps another function. So in this example I have decorator and then I have this function. So I pass one function to the decorator as an argument, and then this wrapper adds extra functionality and then calls the function, and then it returns. So in Python the syntax to do this, to simplify this thing here, is to use this syntax here, which is the @ symbol with the name of whatever the decorator is, and you put this on top of the function that you want to add extra functionality. And Python has a bunch of built-in decorators that you can use. I'm going to put a picture of some of them on the screen now. And JavaScript doesn't have a special syntax for this, but you can achieve the same effect by just wrapping one function inside of the other. In this video I'm going to explain how the import and export system works for both Python and JavaScript, and I'm going to start with the JavaScript. So in JavaScript you can use the keyword import to import code from one file into another one, and then you specify what you're going to import from that file, and then you put the from keyword, and then you specify the path of the file inside of this string here. And if you use one dot, that means the same directory. So the math file is here, which is the same directory that my import file is at. But if I want to specify one directory above, I will do it like in this file here, which is inside of the sum folder, and then I'm specifying with the two dots that the other module is on the directory that's one level up. And if you want multiple level ups, you just keep doing the same thing. So here, if I put it like this, it would be 2 levels up from the directory of this file. And everything you want to import in a file in JavaScript, you have to export on the other file. So here in this case, in the math file, I have to export whatever it is that I want to use on the other file. So to do that, you just use the keyword export, and that's going to allow you to use those things in this file. The other thing to note here is that I'm using the curly braces here, and this is something called destructuring, but I'm going to explain this on the next video. And another thing that I want to explain is that you can use this as keyword in order to allow you to write a function or whatever you're importing as a different name than the original name. So for example, here I have the cat function from this other module, so the name is cat, but let's say that for whatever reason I don't want to write cat, I prefer to write dog, then I would use this as keyword here and then write whatever thing that I want the function name to be. And in that way, instead of writing cat, I would write dog in the file, and then you would understand that what I'm actually calling is the cat function. And the last thing that I want to explain about JavaScript is that you can use this default keyword here as well. So you do export and default, and what this is going to do is going to specify that the default export of the file is going to be whatever you specify here. So in this case, this is a project that I was working on. I'm exporting as the default is landing page, which is this function here. So in Python, the way that you do imports is just using the import keyword as well. You can also use the from keyword, but in this case, you would have to use it at the beginning. So if you use from in the beginning, then the name of whatever module we're going to import, then use the import, and then whatever thing you're going to import from that file. If you use the star operator, then that means you're importing every everything from that module. And it's not recommended because then in very big projects, it becomes difficult to know where the things that you're using are coming from. So it's always better to specify exactly what you're importing from the file. And if you don't want to do this, you can just do this, and then it imports all the file as well. So if the file is on the same folder, you don't need to specify the path. You just do it like this in the second line here. But if the file is on another folder, then you can use the dot notation to access that. So here I'm accessing by first going to the sum folder, and then dot notation, and then I'm importing this another file here in this directory. But there is some nuance in Python, so I'm gonna have to explain some other things for you to understand this. But you can do something that is called relative imports. So for example here, if I want to import this app file into this another file is on the one folder deeper than the app, so I would have to go one level above. And to do that, you also use the dot notation. So you use two dots to go levels up in the folders structures. But the problem with this is that Python has a different way of viewing files, and there's three main things that you need to know. One is that if you have an init file, the dunder method like it is here, dunder method init.py in the folder, then Python is going to consider that as a package. And there's also two different types of files in Python. One is a module, which is a file that is meant to be imported into other file, and another is a script, which is a file that is meant to be ran by itself. So the way that Python knows this is by this name dunder method here. And what this means is that whenever a file is meant to be run by itself, the name of the file is going to be main. So whenever you put this if name equals main, what you're saying to Python is, I want this file to be ran as a script. So if you import this file on another file, then the code in this file is not going to run. It's only going to run the stuff you have after this if name equals main when you run this file directly in the terminal. So in VS Code, it would run like this, run Python file in terminal, and then the code runs. And if you don't put this, then whatever code you have here, when you import on the other files, is going to run. So here, before Python does anything with this file, it runs the code for this file here and this other file as well. And the other thing that you have to understand is that whenever you're doing relative imports, you're not going to be able to run a script, because when you run the script, Python considers the file to be at the top of the folder structure. And for doing relative imports, you need to have a parent package specified. So because Python thinks that the file is on top of the structure, it doesn't understand that you may or may not have different packages on other folders. So it doesn't understand the folder structure, which doesn't allow you to run the file as a script when you do relative imports. And that's a common issue that people face. So one hacky way to get away with doing relative imports and running a file as a script is to use the sys library and do it like this here. But this way is not recommended because of this. You can read it yourself here, but I'm not going to explain now. This is the explanation, but it's not very recommended. It's just a hacky way to do it. So the other thing that you can do to run the file as a script when you're using relative imports is to run from the terminal and use the M switch. So whenever you type Python on the terminal, if you have Python set up on the environment variables, I made a video about that a while ago. Go watch that video to understand how that works. But whenever you use Python, you're going to activate the Python executable that is set up on the interpreter of the IDE, which in most cases is going to be your virtual environment if you set up. I also made a video about that. Go watch that if you don't understand it. But then if you use the M switch, which is this R flag, whatever you want to say it, so Python and then the M flag, and then you put the name of the script, then what this is going to do is going to allow you to run the file as a script with relative imports, because in this way Python is going to understand the whole structure of the project. But the only thing is as well, you need to have this dunder init file on the parent directory. So Python understands that there is a parent package to that file, and that way the relative import works. And the other solution that I found to this, which is another hacky way to do it, but it is possible, is to, whenever you want to do relative imports, instead of running the file as a script from the file directory, you create another file at the top of the directory, and then you make that file import whatever script you want to run, and then you run the script from this file. So in this case, let's say I wanted to run another, and the another is on this folder, but then the another file has relative imports. So instead of trying to run this file directly, I would run it from this app.py here. I made a mistake on the last clip, so just to clarify, you don't actually run the file, you run the function instead of the file. So if whenever you want to run functions after importing the file, you have to specify with the dot notation what you're gonna access from the file you're importing. So in this case, you're importing this another file, and then you're calling this some func here after. So you don't call the file directly. The next couple of videos, I'm gonna talk about some nuances of JavaScript, and in this video, I'm gonna start out by talking about block scope, destructuring, and hosting. So in JavaScript, every time you put square brackets, you're creating a different scope, and it works pretty much in the same way that a function works, where if you declare variables inside of a function, those variables are not accessible through the global scope. So if you declare variables with the let or the const keywords inside of any place that has square brackets, then you're not going to be able to access them outside of that scope. So in this case here, if I console log these two variables, I'm going to get an error because they are declared inside of the scope scope of the square brackets, so they don't exist in the global scope. But if you declare them with the var keyword, then you can have access to them in the global scope. So in this case, you would get 5 instead. So that's one fundamental difference between the var and let keyword. So another nuance of JavaScript that is important to understand is the concept of hoisting. What that means is that every time you declare a variable with the var keyword, it's as if the variable is declared on the top of the file. So in this case here, I'm console logging x before I declare the variable x equals 5, but I do get undefined here instead of getting an error. And the reason why is because this variable is passed to the beginning of the file. So it's as if the declaration is done here because the interpreter puts the variable on top of the file. But the declaration is not moved to the top of the file, only the variable is. And that's the reason why you get undefined instead of getting x equals to 5. So the declaration is still stays here, but the variable x is passed to the top. So by the time this console log is done, you get undefined for the value of x. And with let and const, you have hoisting as well. They are hoisted to the top of the scope they are at, but the difference is they don't have a value when they are hoisted, and then this makes it give an error instead of getting undefined, because if you declare with var, then the variable still has a value which is undefined, but if you declare with let, although they are hoisted to the top, they don't have a value, and because of this you get an error. And with functions is the same thing. Functions are also hoisted to the top of the file, so you can call the functions before you even declare them because they are put on the top of the file by the interpreter. So the last concept for this video is the structuring, and the way that it works is pretty much a convenient way to initialize variables. So if you have an array, for example, you can initialize the variable with an array. So in this case, you're using 3 different variables, a, b, and c, and then you're making equal to the array. And what's that gonna do is gonna make each variable equal to each element of the array instead of having to initialize them one by one. So it's just a convenient way to do it. So you can also do this with objects as well. So if you're doing with objects, you have to use the curly braces. If you're doing with arrays, you have to use the square brackets, but it's pretty much the same concept. So here you're accessing the value of the key name directly by using the square brackets. So this name is going to be equal to John, and the age is going to be equal to 30 directly because you're using the structuring. And if you want the variable to have different names, you can use this technique here, which you use these 2 dots, and then you put whatever name you want the variable to have instead. And that allows you to create variables with different names than the original object had. And in Python, you have a very similar concept, which is called unpacking. The only difference is in this case, you're not using square brackets, you're just separating the variables with the comma. And then here there's an example with tuples that works the same way pretty much. And then you also have the option to not use one of the variables that it is inside of the array. And you do this by putting this underscore here. So whenever you see an underscore in a Python program, it's just a convention. And what it means is that this variable is not supposed to be used on the program. It's just an empty variable, let's say, a variable that shouldn't have a purpose, but it's not something that is special from the language. It's just a convention that people do. And also, if you use an underscore before a variable, that means it's a private variable, but it's also just a convention. It's not something from the language. So yeah, that's it for the video. See you next one. In this video, I'm going to talk about event listeners in JavaScript. I'm not going to explain HTML because the purpose of the video is JavaScript, so go learn that if you don't know before you watch this video. But here I have a simple HTML page with a div with the class container. And then the way that you are able to manipulate this div in JavaScript is use something called query selector on this document object. And document is a global object in the browser. So you can use this query selector, and then inside you use this dot to say that is a class. And if you want to grab an element by the ID, you would use the hashtag, and then you use whatever name the element has. In this case, the class is container, so I'm using dot and then container. And then this is going to become the element, the HTML element. And after you do this, then you can change the style of the element like I'm doing here. It's pretty much an object that has a bunch of different properties that you can manipulate in the browser. So here I'm accessing the property of style and then changing the display to flags, then changing the height, which would be the same as doing in CSS. But in some situations, you want to change the functionality, change the style of the div based on the functionality. And that's why you would do this on JavaScript. And then here I also have to talk about an extension that you can use. It's called Live Server on VS Code. So I already have the extension installed, but if you install this, it allows you to open this website in the browser so you can see what is going on there. So you just go open with Live Server, and then this is the page that I have there with the JavaScript, and I'm going to explain what is going on here. So pretty much I have a loop here, and then you can use this create element on the document to create divs as well. So I'm creating a new div from JavaScript, then I'm changing the style of the div. I'm making it have a border with 1 pixel white solid, then putting a height and a width. Then I'm changing the class of the div and making it equal to my/div. And then after that, I'm appending these divs on the container. So this allows you to programmatically add a bunch of different divs inside of another div in HTML. And I'm creating this and everything on JavaScript, and then this container listener is this thing here, which is the container from HTML. And then what you can also do here is use this query selector all, and this allows you to get all the elements of a div. So in this case, I'm getting all the divs that have the class myDiv in the HTML, in which this case is the divs that I added here. So query selector all allows you to get all of them, and then query selector only gets the first one. So after I do that, then I'm looping over them, and I'm calling this thing here, which is called add event listener. And what this allows you to do is to make some function run depending on whatever event you're triggering. And there's several different events. So for example, one of them is mouse enter, which means that whenever the mouse enters the div, it's going to trigger this function here. And this function can be whatever function you want. In this case, I created a function called paint, and I put it here. And then I have this other event, which is mouse leave, which triggers a function when the mouse leaves the div. And in this case, I have this other function here called paint back. And what these functions are doing, they are changing the background color of the div. So you can see when I hover the mouse over them, it changes the background color to white, and then when it leaves, it changes to black, just like it is here. And there are several different other things you can do with this. There are several different events that you can trigger here, and it's very common to do this because the most common example, the most used example is probably adding a functionality to a button. And I'm sure if you use websites, you've seen this before, where whenever you click some button, it does something. That's happening with an event listener. So you create a button on the HTML, and then from JavaScript, you are able to add these event listeners and make certain functions run whenever there is an event that gets triggered. Another thing that I want to say on this is that usually you're going to see these event listeners inside of an HTML element. Like it is here, I have a farm element, and then right next to the class name, I have this onSubmit, which is an event listener, which is a slightly different way to write it than the way that I just showed, because it's inside of a framework from JavaScript. So you put the name of the event listener, then you make it equal, and then inside of these curly braces, you put whatever function you want to run once the event gets triggered. In this case, I have this handle submit function here, which is declared here. Then another way you can do it is like it is here. In this case, you have the onShare event, and then same thing, equal, and then here you have the function directly inside of this event using the arrow format. And this is usually done when the function is very small, so it's more practical to do it this way instead of creating a function in another place and then putting the name here. And another very common event listener is this onChange on email forms. And the reason why this is usually done is because then you can put this function like it is here, and you can access the user input through this event.target.value. This allows you to access whatever the user is inputting on the inputs from HTML, which is usually the email or something like that they're gonna send for validation and things like that. So this is a very common pattern as well. And the other one is obviously the onClick event, but I don't have an example here, but it's usually done when you want to click a button and some functionality happens, then you use the onClick event. The last thing that I wanted to mention here is that you can use something called a canvas. So I have another HTML here, and then you can use this element, which is a canvas element from HTML. Then here the idea is canvas, and then you can get this element using the query selector again on JavaScript. And here notice that I'm using the hashtag because I'm getting by ID. And then you can access this get context method from the canvas object. And what this allows you to do is to draw things on the screen or to do animations. It's an easier way to do animations. And then there's a bunch of methods that you can use. Here I'm setting the canvas width and height to the window inner height and width. Then selecting the fill style to black, the line width to 10. And then I'm getting the mouse position here. And pretty much through this code here, I'm able to draw things here. And I'm not gonna dive deep into this because that's not the point of the video, but I thought it was worth mentioning because it's also something that is very common for people to do, because usually you can do this to make those animations that you have on the site of maybe a snowball effect or things like that. And there's a lot of cool things you can do with this, but yeah. And the way that you do it is also by using some event listeners here on mouse move and mouse down. Mouse down is when you click, mouse move is when you're moving the mouse around. And another thing you can do with event listeners as well is you can get the position of the mouse in the screen. And yeah, that's usually the kinds of things that are done the most with event listeners. So that's it for this video, and see you next time. This video I'm going to explain async await, and first I'm going to talk about the syntax, then I'm going to dive deeper into how it works. Well, pretty much the way that it works is that you have clients and servers in the internet, and client is your own computer and server is a computer somewhere in the planet, and they communicate through cables which connect the whole planet, and that's the internet. So it's a bunch of cables that connect the whole planet and a bunch of computers together. And then through these cables you have a bunch of signals that are being transmitted. So your computer sends a signal through the cables, and that signal reaches the server. Obviously this is an oversimplification, but so just so you understand. Then when the signal that you send gets to the server is going to interpret the signal, and then depending on the code that you have on the server for running the website, it's going to respond with another signal, and then it's going to go back and forth, and that's how the information is passed, and that's what generates the websites that you see. query. So usually the way that people talk about this is by using something called an API, which stands for Application Program Interface, and it's pretty much a shorthand way of saying the way that computers communicate. So through these API calls, you communicate back and forth between clients and server. That's a very common thing to do. But the problem is these API calls they don't happen simultaneously, and that's an issue because your code wants to run. Let's say that you're calling a function, you're sending some information to the server, and then the server is going to send the information back. But let's say that the server, for whatever reason, is going to take like 5 seconds to respond. But the problem is your code is not going to stop executing until that response is sent. It continues executing, and that's the issue because maybe there's something in your code that depends on the response to execute correctly. So in this case, the code would crash, but it's not because there is a problem, it's just because the response is not fast enough. And that's the point of having async await. It allows the code to wait until the response gets there, and so that it only continues executing after that. And the syntax for this is async here. You use async before a function, the keyword async, and then inside of the function you use await for whatever function or whatever piece of code you wanted to wait until the response gets there. And in JavaScript, in Python, the syntax is pretty much the same. You use async before the function and then await whenever you want the code to wait. And they have slight differences, but I'm not going to dive into the differences between Python and JavaScript in this video. I'm more going to focus on JavaScript because otherwise it would take too long. So there are two functions I want to explain here, and they are both built-in functions from JavaScript. One is set timeout and the other is set interval. And the way that they work is they receive a callback function and a number as the second argument. And then the number they receive is going to determine the amount of time the code waits until it executes the callback function. In set timeout is going to execute this callback function only once, and in set interval is going to keep executing the function on that time interval that is determined by the second number. And these numbers are in milliseconds. So here I have 3000, but in reality it's just 3 seconds, and here I have 9000, and in reality it's 9 seconds. So when I execute this file, it is going to wait for 3 seconds, and then it's going to output timeout here, and then waits for 9 seconds and console logs B. And if you want the interval to stop running, you have to call this clear interval and then pass the name of the function to this as an argument, and then it's going to stop the set interval. And the reason why this is important to understand how async works is because that's pretty much what async is under the hood. It's just a set interval function. And then there's a problem that I'm going to explain shortly, which is callback hell. Another thing that is important to understand is that set timeout is only going to execute after all the other code is done. So even if you put 0 as the time here, it's still going to wait for all the code to be done, and then it's going to go back and execute the callback. So in this case, I have console log start here, then timeout and end. And in the normal way it was supposed to go, you would first console log start, then timeout, then end. But the way that it works here, you console log start, then end, and then goes back and console logs timeout. So if I run the script here, you can see that it's first start, end, and then timeout. So whenever you're using these functions, they're gonna execute after all the other code is done executing, regardless of how long it takes. So the idea of async await is to use the set intervals, and that's what it uses under the hood. So instead of the program continuing to execute, you put it on the set interval, and then it waits until an API call or something like that happens, and then the callback function executes and the execution continues. But one problem people faced when using set intervals is that when you have multiple different calls you want to make, when you want to use set interval multiple times, it ends up being like this, where the result of one set interval goes into the other one, and it cascades like that. And when you do it like this, the problem is that each callback can return at different times and becomes very difficult to debug and understand what's going on. And the name of this issue is callback hell. You can look for yourself one. And the way that people came up with dealing with this is they created an object in JavaScript that the name is promise. So instead of doing things like this, you can simply chain different promises, and it's a lot easier to read and debug the code. So instead of doing things like the way that it is here, you create a promise like this. So it's just like creating a class, and then the promise accepts a function, and the arguments of these functions are resolve and reject. And the promise can be in 3 different states, either is pending or fulfilled or rejected. So it's pretty self-explanatory. And then you chain these promises like this. You put this dot then after calling the promise. So this dot then receives a function, and the argument of the function is going to be whatever the result of the promise is. And then you can put multiple dot then statements one after the other, and it is the same as doing this thing here on the left. And then at the end you put this dot catch, which catches errors if the call is not successful. And then it's the same thing with the then, that you receive the error as an argument, and then you can console log the error. Another common thing to do when you're doing operations like this with async await is to put the code inside of a try catch block. And the reason why is because oftentimes you have situations where the API fails for whatever reason, but you don't want the code to stop running so that it doesn't break the whole system. So that's the purpose of the try catch block. It allows the code to continue running even if there is an error error, and then you catch the error on the catch, and you can also error the error as well. Then the last problem they had with this is that even if you do things like this, chaining different dance statements, you still have a situation where it's not very efficient because you have to wait for the execution of one call to be done so that the other one is made. So what people invented is this promise all here. So it's promise.all. And what this allows you to do is pass an array of different promises, and then they are all resolved simultaneously. But the only issue with this is that there is no way to know which one is going to resolve first. And another note here on this is that this doesn't solve the issue of callback hell. It just makes it easier to write the code and debug. But under the hood, you still have the situation that it is like this because the promise is using set intervals and set timeout to do the functionality. And another thing that is worth noting is that there's this distinction between micro events and callback queues. And the way that this works is that in Node.js or different runtime environments, you have different queues, which is the way that the program determines what is going to run next. And the callback queues are put on a different list of priority than the micro events. So micro events have higher priority than callback queues. And what that means is that a promise is a micro event, and it means that it's going to be executed before a callback function is. So it has higher priority in execution than a callback function. But they both have less priority than a macro event, which is just a normal code or normal function. So they both execute after all the code is done executing. And I think that's it for this video. So yeah, this is it for this series as well. I might make videos more about the frameworks and different libraries from JavaScript because learning the two languages is just the beginning, the syntax, everything that I mentioned here. And in order to truly know how to use the languages, you have to become familiar and proficient with the most used libraries and most popular libraries. So I might make videos in the future about them, but not 100% sure. I think next videos I'm probably going to be shifting more towards crypto or data structures and algorithms. So see you next time.